to this university to organize this webinar. I also welcome co-patron of the webinar, Dr. Mridula Bellore, conveners, reporters, and all who associated with the organization of this webinar. I welcome to all faculties, students, and other participants who are joining the webinar and take the advantages from this scientific sessions. Now, thank you very much, sir. And now I request Dr. S. Rao to deliver inaugural address. Sir, Dr. Rao, sir, please. Dr. Rao, sir. Dr. Rao, sir, please deliver your inaugural address and guide us, sir.
Good morning to everyone for PSC and JNKVV, Dr. Chaudhary Saab, DDG, NRM, ICR, New Delhi, Dr. PC Sharma Saab, Director, CSSRI, Karnal, and Dr. Barman Saab, Head Soil Science, Regional Research Station, Cannington, or Dr. MJ Kunkar Saab, Project Coordinator, ASRP, Central Soil Salinity Research Institute, Kerala, Dr. Vermaji, former head of the department and the previous project in charge of the salt affected areas in Madhya Pradesh, and other distinguished participants and the registered students and the faculty members and Director Research Services of this university, Dr. MP Jain, and the distinguished directors and deans and the faculty members of the RVS KV Gwalior. I welcome all of you on this today's webinar on nature and extent and management of problematic soils for sustainable agriculture. And this is a very important topic relevant to the today's contest. As you are all aware that we are self-sufficient today in food production in many commodities, leaving oil seeds, but we have to assure the sufficient food requirement looking into the demand of the food with the growing proportion to the growing population. This is a very important requirement. We have to increase the productivity from the existing land, and then we have to work out what are the possibilities to bring them the problematic soils also in as a productive area to add to the food basket of the food production. And looking into these circumstances, now if you look at the existing areas of cultivation, there has been a decline in the area of cultivated area every year. When one side area is declining, cultivated area, another is population is increasing, food demand is increasing. Under these circumstances, the better option is that we have to identify what are the untouched areas where we can enhance the productivity of these crops. One is problematic soils is one area where we can find out the management practices, we can work out the technologies, we can develop the suitable varieties suitable for cultivation in these problematic soils, and then we can enhance the food requirements, food productivity, and food production in these soils also, so that future requirements can easily be met. Of course, the area in these problematic soils is not so big, but it is a problem for the landowners, those who are having. If they don't have the technologies, they cannot, their livelihoods are affected. They cannot get the better returns out of that. They cannot get the better returns out of that. Under these circumstances, the better option is that simultaneously we should work out the management practices that is easy to do it and use it to develop the technologies and simultaneously and enhance the productivity and make it as a profitable cultivation in the problematic also. And a lot of areas are there in the Gujarat and other states. Even Madhya Pradesh is not so much of area, very limited, very much scattered, what I know, my limited knowledge. And anyhow, whatever it is a limited area or a bigger area or a scattered or consolidated, whatever it is, and these areas needs to be addressed thoroughly by the experts, and then it has to be brought into the cultivation, because there is no possibility of increasing the geographical area. Within the geographical domain, demography, we have to bring the more area under the cultivation, these type of problematic soils. With these few words, I welcome all the distinguished speakers of the today for having the presentations and giving their views on this very important topic. Thank you very much for all of you for accepting our invitation and participating in this. Thank you once again.
And now Dr. Bangar. Dr. Bangar, please start the webinar with the key address of Dr. Kumar. Dr. Bangar.
Hello, good morning everybody, sir. I am Dr. K.S. Bangar. Sir, I invite Dr. V.S. Thomas up for the lecture. Before inviting Dr. Thomas, I would like to say something about the biodata of Dr. V.S. Thomas. Please, sir, Dr. V.S. Thomas was born on 1st July 1946 in Morena district, and Thomas did his BSc Agriculture and MSc Inter from JNKB Jodhpur and PhD from GB Pant Agriculture University, Patnagar in Soil Science and Agricultural Chemistry. He also did his postdoctorate from the International Rice Research Institute, Manila, Philippines. He was the recipient of postdoctorate fellowship from Irving, Philippines, ICR Senior Fellowship PhD, and University ICR Merit Scholarship BSc Agriculture and for MSc Agriculture. He has a 40 years vast experience in soil science and soil physics also, sir. He is soil health and water management, etc. And Professor Thomas was a recipient of postgraduate fellowship. That is, and rather he is, was a founder of Vice Chancellor of Rajmata Vijayaraje Scindia Krishi Vishyavidhyalaya Gwalior and immediate past Vice Chancellor of Jawaharlal Nehru Krishi Vishyavidhyalaya Jabalpur during 2012 to 2017. Before such a respected post, he occupied various dignitaries posts in JNKV Jabalpur as a director of research services, DVS, and director of structure, etc. Yes, sir.
Please stop here. Enough.
Okay.
Thank you.
Okay, sir. Thank you. Thank you very much, sir. So I invite Dr. Thomas, please. Yes, sir. Yes. Please start.
Honorable Vice Chancellor of Rajmata Vijayaraje Scindia Krishi Vishyavidhyalaya Gwalior, Dr. S.K. Rao. Our colleagues from CSRI Karnal, Dr. Yadav, Dr. Burman, Dr. S.K. Chaudhary, the Deputy Director General from ICAR, our colleagues Dr. Burma, Dr. Bhavan, all the deans and directors of the university, professors, scientists, and students of the Vishwavidyalaya, all participants. And probably if some farmers are there, I take this opportunity to welcome all the experts and all the participants. Friend, the situation of degraded land is अरे पटेल अरे यार ये क्यों नहीं आ रहा है क्यों नहीं आ रही है
कुत्ते फानते आना जरा
स्लाइड
अरे आएगी
क्यों नहीं आ रही
आएगी 2 मिनट सर 2 मिनट ये ओपन कर लीजिए
स्लाइड तो ओपन है
आइकॉन नीचे अपना वो प्रेजेंटेशन वाले आइकॉन पे क्लिक कर दीजिए यहीं पे और नीचे थोड़ा और नीचे अरे वो आइकॉन दिख रहा है सर टास्क बार पे यही अरे नीचे आइए सर नीचे वहां नहीं नीचे आइए और नीचे आइए और नीचे
थोड़ा तो कुछ है ही नहीं
अरे है सर वो दिख रहा है हमको तो दिख रहा है ये दिख रहा है आइकॉन
कौन सा आइकॉन बताओ अब तुम
अब फिर से शेयर करो सर फिर से शेयर करो
ओके
अभी पहले अपनी फाइल मिनिमाइज कर लीजिए
ओ फाइल को मिनिमाइज करना है
हाँ अपनी पहले फाइल मिनिमाइज कर लीजिए
मिनिमाइज के चक्कर में चली गई यही मैंने कहा था ना यार पहले तुमको
कोई बात नहीं सर, आ जाएगी। आप शेयर स्क्रीन करिए ना फिर से।
मैं इसको मिनिमाइज करूं?
पहले आप अपनी प्रेजेंटेशन फाइल को मिनिमाइज कर लीजिए।
ओके ओके
मिनिमाइज हो गई।
एक
अब
सेकंड,
आप
ये
फिर से शेयर स्क्रीन
तो
पे जाइए।
मतलब मिनिमाइज ही है यार ये।
हाँ कोई बात नहीं, अब शेयर स्क्रीन पे जाइए ना फिर से।
हाँ।
शेयर स्क्रीन पे क्लिक कीजिए।
शेयर तो हमने क्लिक किया।
कोई बात नहीं, नीचे जहां से आपने पहली बार किया था ना, वहीं
अच्छा,
पे
वहां पे जाओ।
कोई बात नहीं, हो जाएगा हो जाएगा। शेयर स्क्रीन ऑप्शन मिला आपको? नहीं, बॉटम ऑफ दी स्क्रीन देखिए ना सर, बहुत सारे लोगों के इमेजेस के नीचे। अभी आपने शेयर स्क्रीन कहाँ से किया था?
यहाँ से किया था।
हाँ तो वहीं क्लिक कीजिए ना फिर से।
अब हो ही नहीं रहा।
अरे होगा सर, ऐसा हो ही नहीं सकता। देखिए मैं शेयर स्क्रीन करके दिखाता हूँ आपको। देखिए मैं अपना स्क्रीन शेयर करता हूँ।
इसको नहीं कर सकते?
नहीं, अब उसको करने के लिए मुझे बहुत कुछ करना पड़ेगा। ये देखिए मैंने अपना स्क्रीन शेयर कर दिया, अभी आपको दिखेगा। देखिए ये दिखने लगा।
हाँ,
ये हमारा स्क्रीन है, बस आपको नीचे जाना है और शेयर स्क्रीन पे क्लिक करना है और कुछ नहीं। अब मैं स्टॉप शेयरिंग कर रहा हूँ, ये कर दिया।
टीवी बना है ना इस पे।
सर
देखो
आपके सामने, एक मिनट, आपके सामने जो स्क्रीन डिस्प्ले हो रही है जिसमें सब लोग दिख रहे होंगे,
हाँ
दिख रहे हैं, उसके नीचे
हाँ,
भी छोटे छोटे पार्ट में दिख रहे होंगे।
उसके नीचे देखो म्यूट, स्टॉप।
हाँ उसी के आगे कैम स्कैन के आगे शेयर स्क्रीन लिखा है।
हाँ
हाँ तो शेयर स्क्रीन पे क्लिक कीजिए ना।
किया।
अब एक डायलॉग बॉक्स डिस्प्ले हुआ होगा आपके कंप्यूटर में।
हाँ,
उसके उसके जो स्क्रीन मॉनिटर का या आइकॉन दिख रहा है पिक्चर, उस पर क्लिक कर दीजिए तो शेयर बटन एक्टिवेट हो जाएगा। और फिर शेयर पे क्लिक कर दीजिए। हाँ अब आ गया। अब मैं इसको ऐड
आ गया?
करता हूँ। हाँ ये आ गया। अब देखिए आपके टास्क बार में वो प्रेजेंटेशन का आइकॉन दिख रहा है, उससे अपनी फाइल ओपन कर लीजिए। आपके
फाइल ओपन
कंप्यूटर में वहां नहीं जाइए सर, नीचे आइए। यही 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 ये थोड़ा और साइड में
लाल वाला। हाँ ये
लाल वाले पे क्लिक कीजिए। लाल वाले पे, इसी पे, हाँ कर दीजिए। यस
ये आ गया।
अब इसमें फुल स्क्रीन वाली क्लिक कर दीजिए।
है?
फुल स्क्रीन वाली वो कप पे जहां से प्रेजेंटेशन करते हैं, फुल स्क्रीन प्रेजेंटेशन करते हैं ना सर,
हाँ,
वो कप पे क्लिक कर दीजिए ना। ये कप दिख रहा है।
एक सेकंड।
हाँ, अब स्टार्ट कर दीजिए। अब आपको अपना केवल प्रेजेंटेशन दिख रहा होगा और कुछ नहीं दिख रहा होगा।
ओके, ग्रेट, थैंक यू वेरी मच। Thank you very much. I'm sorry. I'm extremely sorry. I'm not very good in management of all these things. Anyway, friends, the problem of problematic soils or the degradable soils is really very high in our country. Now, if we see the demand of food for increasing population, then it is huge. And at the same time, the soil is getting degraded. The productivity is going down. At the same time, the land area is also decreasing. But we have to produce more. How to do that? With the usual business of soil management. Can we do that one? When food grain requirement will be more than 400 million tons, 2050, and population will be more than 1.7 million. Per capita land availability in our country is less than 0.1 hectare. Whereas, in general, this is the recommendation that each person should have at least 0.4 hectare land. And you can see in some of the developed countries, they have enough land. But in our country, the land area for per capita is very limited. Soil health management, deterioration. Soil health refers to the quality of the soils, and it refers primarily to continued capacity of soils to function as a vital ecosystem and that sustains the plants, animals, and humans. It's very important that living ecosystem. Soils have lot many key functions, including food production to environmental quality, then biological habitat, and it is a source of many raw materials. At the same time, we need not much area for buildings, roads, and everything. At the same time, the constant for increasing crop productivity are developing. Soil are getting degraded. We are going for highly imbalanced nutrient supply, decline in organic carbon, and so on, including the climate. Soil degradation, again, it means the functioning capacity of the ecosystem decreases. Now, how to improve upon? Otherwise, if we will not improve, then the input use efficiency, availability of water, nutrient, everything is going to be very, very low. Hence, if you see the situation in our country, land degradation is in the range of 114 to 147 million hectares. Primarily, water erosion, nearly 64 million hectare land is under water erosion, and this is increasing every year. This is increasing every year. There is no control on that. At the same time, wind erosion, salt-affected soils, waterlogging, soil acidity, and complex problems. Complex problems are associated with the development of roads, buildings, and cleans your the bricks, and so many things. So many things are dependent only on soil, and we have limited area available. Annual soil loss is nearly somewhere around, you can imagine, 5.3 billion tons, and which is equivalent to 8 million tons. And that is the deficit. Every year we have nutrient deficit in our soils equivalent to 9 to 10 million tons. The average soil loss from our soils is 16.4 tons, whereas the tolerable limit is only 4 to 5 tons. Your vertisols are highly degradable. The losses are more than 20 tons per hectare per year. Because of soil degradation, the huge impact is there on agronomic productivity and functionality of the soil. To produce more, we must improve input use efficiency, that is nitrogen use efficiency, fertilizer use efficiency, water use efficiency, and other inputs. Input use efficiency can be improved by restoring the degraded lands. Friends, huge amount of fertilizers are being used, but in imbalanced form. The nutrient supply is highly imbalanced. At the same time, the gap between the nutrient requirement and the supply is increasing. On an average, every year, we have a nutrient gap of nearly 10 million tons per year. At the same time, the partial factor productivity of our nutrients is declining. And this declining is following a basic principle of law of diminishing returns. Now, that is very important. We must look into really, we are applying huge amount of fertilizers, but the utilization of that is very, very limited. Why nutrient efficiency is low? Nitrogen not more than 30 to 50 in general for all crops. Phosphorus in the range of 15 to 20 only, potassium little higher, sulfur only 8 to 10, and micronutrient only 1 to 2%. Friends, if you see the nitrogen use efficiency in cereals, where the requirement is very high in our country, this is only 21%. And compared to US and China, we are at the bottom. We have to improve the nitrogen use efficiency, and you can imagine that every year we are adding more nitrogen and less P and K. That is the government policy of ISIS. Even Prime Minister Modi indicated that the nitrogen use in terms of urea must be reduced. Cut urea use by 50% by 2022. This is his slogan, and we have to do really. We are reaching 2022, and we are not making much efforts to reduce the nitrogen use in our fields. At the same time, the multi-nutrient deficiencies are increasing, primarily due to imbalanced fertilizer use, primarily also due to more mining by crop production from different soils. You can see that on an average, every year, every 10 years, nearly 1 to 2 nutrients are being added which are getting deficient in our soils. Very poor situation. All the micronutrients almost are essential for plants, animals, and humans. And the efficiency of application is not more than 1 to 2%. What to do? Zinc deficiency, it can create many problems if our soils are zinc deficient. Similarly, the molybdenum deficiency. If we add little more molybdenum, and the yield can be increased considerably. It is reported from our scientists working at CEHO that nearly 15 to 20% increase in chickpea yield only by application of 1 kg per hectare ammonium molybdate or 1 to 2 gram kg per kg of seed as seed treatment. Similarly, zinc application in cereals has shown very good impact. Yields have been found to be increased by nearly 20% or more in some of the cases. Climate will also affect the degradation of our soils or the agronomic productivity. Primarily, the CO2 emission is very high from our soils. Of total CO2, agriculture and land use change contribute to nearly 25%. So, like that, the emission of methane, nitrous oxide is also used from our soils. At the same time, the availability of water is getting reduced, and that is resulting in the development of droughts in many areas. Yield is directly dependent on soil moisture. This is very well known. We must look into these things. At the same time, because of climate change, the uptake of nutrients by plants in terms of foliage as well as in terms of grain is reducing almost in all the crops and all the nutrients. At the time when we double the CO2 in the environment of crops. Then what to do for managing these soils? Soil health primarily the physical, chemical, and biological properties, and all are being affected by degradation of the soils. Maybe your biological system, maybe chemical deterioration, as well as the physical deterioration. It is recommended that we must go for integrated approach based on site-specific recommendations. And at the same time, we must improve the nutrient and water management practices, use suitable crops and cropping pattern, and apply fertilizer as per soil test values. What to do for mitigating the GHG emission? CO2 primarily. For controlling the reduction of CO2, we should do something, or either we can reduce the CO2 efflux or we can go for carbon sequestration. Similarly, for methane, either we can reduce the emission of methane from our paddy soils or from animal byproducts, including dung, or we can increase the methane oxidation potential in our other soils other than the paddy soils. Nitrous oxide mitigation can also involve the integrated nutrient management, site-specific nutrient management, and agricultural operations. The management of soil carbon from all angles is very important. Let us see how to do. The situation of carbon in our soils is not good. On an average, our all soils are somewhere around less than 0.3 to 0.4. With that condition of that much low organic carbon, you can very well imagine how soils are degraded, how much they are really degraded. So for improving the carbon in soils, we must go for carbon sequestration. Soils have huge capacity to retain the soil, retain the carbon in its system. Huge capacity, much more higher than the carbon dioxide in our atmosphere. A little enhancement in soil carbon or yield would represent a substantial carbon sink in our soils. The soil potential to sequester carbon can lessen the intensity of climate change also. Here, we have given some data that shows the increase in crop yield with increase in soil organic carbon by 1 ton carbon per hectare. If we can add 1 ton carbon per hectare, means that is equivalent to 0.1%. The yield increase is there considerably, match 100 to 300 kg per hectare per ton of carbon per year. Soybean, wheat, rice, almost in all crops, there is improvement in the yield. And that's very important, not only yield, but many other functions, the physical system, the biological system, the chemical system, they are all governed by the carbon in the system. Next important issue is related to selection of crops and crop input systems, whereas we must go for inclusion of legumes in our cropping system, like growing of pigeon pea on rice bunds, or having pigeon pea in intercropping with soybean, and so many other good intercropping systems are available in our country. The next issue is related to integrated farming system. If we have integrated farming system, then it will again help in improving the carbon in our soil system. We can go for many things, maybe goatry, maybe poultry, maybe dairy, maybe fishery, like that. We must go for some of the integrated farming systems. The integrated nutrient management technology. It is very much well proved that if we use the nutrients in integrated form, means some chemicals, nearly 50 to 75% chemicals, plus organic matter, availability of organic matter, including the biofertilizer, rhizobium for your pulses and BSB for cereals and other crops. Another important point is the CA. The conservation agriculture can reduce lot of burning. At the same time, it can help in improving the quality of the soil. It can improve the water retention capacity, nutrient retention capacity, as well as it will stabilize the widespread of soil degradation and will have direct impact on climate mitigation. Protecting soils with crop residues. We can do much with crop residues. Huge amount of nutrients are being added, huge amount of carbon is being added. Therefore, we must go grains, we must think from the viewpoint of grains for people and residue for soil. Huge benefits, short-term, medium-term, as well as long-term benefits of conservation agriculture are there that recommend that we should go for conservation agriculture. Then organic mulching, it will help in conservation of water losses. At the same time, will add a lot of carbon in the soil. Crop residues contain huge amount of nutrients. Now, if we see the crop residue available in our country, it is somewhere around 664 million ton per year. And this can add, if we manage it properly, only if 50% of that is used, then it can add nearly 266 million ton carbon per year. Huge amount of carbon can be added from this crop residue, and that will be somewhere around, if 50% is recycled online, then the amount of carbon will be 13.3 million ton carbon per year can be sequestered. So huge amount of carbon can be added only if we recycle 50% of our crop residues. Similarly, for animal dung, if we use only limited amount of that, 50%, if 562 million ton dung is used for biogas out of the total available, it will add nearly 11 million ton per year the carbon. Other management of agricultural waste and post-harvest, huge post-harvest losses in fruits and vegetables are there. Total food grain wastage is also huge. Fruits and vegetable wastage are huge. And if we look into that one, then the soil organic carbon from these sources can be added up to 5.5 million tons per year if only 30% of these waste are recoverable. Only 30%, it can add huge amount. Then municipal soil waste, huge amount of municipal soil waste is there. And the average carbon content of that segregated waste compost is nearly 20%. Carbon captured in municipal soil waste compost will be somewhere around 12.87. Now, if you add all the four crop residues, animal dung, crop waste, and MSW, then somewhere around 42 million tons we can add carbon in our soils per year, 42 million tons. Huge amount can be added. At the same time, there are not much benefits of use of biofertilizers. The use of organic farming, zero budget farming, many other things are coming up. The indirect advantage is that they are going to add enough organic carbon in our soils. But on large scale, the uses are to be yet tested and verified. Then the acid soils. The liming of acid soils can help a lot in restoration of these acid soils. Similarly, the alkalinity, huge amount here in our system. For different cropping systems, recommendations are available, maybe rice wheat system, maybe other systems. The recommendation for improving alkaline soils and improving the productivity of these soils is available. Similarly, for managing the salt affected soils. And if we conclude from the available information, then we must make efforts to restore the degraded soils, and at least we must bring down soil loss up to tolerable limit. That's what we defined earlier, 4 to 5 ton per hectare per year. If we can reduce that soil loss to that level, probably we can save enough water and nutrients in our soil system. At the same time, improve the soil health of degraded soils to retain and supply nutrients and water. Very important. Until and unless we do not improve the health of the soil, the nutrient water retention supply capacity is getting lower every year. For all these things, we must go integrate the nutrient application. Through potential recycling of farm waste, CA to improve the nitrogen use efficiency. Nitrogen losses are very high in comparison to other losses. Other ions are left in the soil, but carbon, the nitrogen is lost in the atmosphere, which is not recoverable at all. So we must go for improving the nitrogen use efficiency, fertilizer use efficiency, water use efficiency, and in general the input use efficiency. That will also help the system, the carbon sequestration in our soil system. The basic strategy to manage soils is through improve the fertilizer use efficiency by 4R. Right source of fertilizer, right rate at the right time, and place at the right place. Soil management also looks for 4S for restoring the soil system, restoring the carbon in the system, the soil health, conservation of soil water, and management of soil temperature. Because only 1 degree centigrade increase in soil temperature can decrease wheat yields nearly 4 to 5 million tons per year in our country. And in general, 17% losses in all crops in general are there because of 1 degree centigrade increase in soil temperature, the atmospheric temperature. We must go for some of the policy interventions also in which the government has to look into the system. We can promote the balanced nutrient use. For promotion of balanced nutrient use, the rate, the prices that have been looked into by the government, that have been decided by the government, has to be really relooked. Because of the low price of nitrogen, people are using more nitrogen and very less amount of P and K. Anyway, when we go for balanced use of nutrients, along with balanced use of nutrients, we must go for integrated nutrient management, including the organic matter and biofertilizers, green legumes, like that. Increase the soil organic carbon through CA and IFS, integrated farming systems. Now, that point for government can be pay for farmers for carbon sequestration. The suggestions are coming from many scientists that we must not go for reducing the prices of fertilizers and other things. We must pay farmers for improving the ecosystem, that is the carbon sequestration in our soil system. Improve use efficiency of inputs, produce more, that's the slogan also given by our Honorable Prime Minister, produce more from less. Right to soil, Dr. Ratan Lal said that soil is considered as a living system. So there should be right for soil system. Friends, with these points in my mind, thank you very much. Thank you all. Thank you very much.
Thank you very much, sir. Sir, you have very well mentioned, sir, nutrient use efficiency, fertilizer use efficiency, and how to improve this integrated farming system. Along with this organic carbon content in soil, which is deteriorating day by day. So, how we can increase the this organic carbon percentage, and how to reduce this soil loss as well as the degradation of the soil. Thank you very much, sir. Thank you very much, sir. Now, I request Dr. R.K. Yadav, please. Dr. R.K. Yadav, please give your presentation. Before your presentation, I would like to say something about your brief biodata, sir. Dr. R.K. Yadav, born on 3rd March 1964 at Dongara district, Mahendragarh, Haryana. Dr. R.K. Yadav, his BSc Agriculture in 1985 and MSc Agriculture in 1987 with distinction. Dr. Yadav obtained his PhD 1991 in first rank from CCS HAU Hisar University, and he joined as a head of Division of Soil and Crop Management CSSRI Karnal May 2015. Dr. Yadav has made outstanding research contribution in field of management and salt affected soils and use of poor quality water, including wastewater in agriculture. He has published more than 151 research paper in international and national journals, 35 review articles and book chapter, 48 popular articles and 5 books and manuals. Dr. Yadav has guided 3 PhD students and 3 MSc agronomy students. And as far as the award is concerned, he recognition to his scientific contribution. He has been awarded National Groundwater Augmentation Award of MOWR of Government of India, Ganesh Shankar Vidyarthi Award twice of ICR. He also received the ICR CSSRI Excellency Award 2016. As far as the fellowship is concerned, he received CSIRO Fellowship of Australia for improved prediction of agroforestry and reclamation opportunity in shallow water table and salt affected landscape in India during 2001. Since 2001, he has been serving as a key resource person of African Asian Rural Development Organization and TST for capacity building of African and Asian researchers on poor quality water management in agriculture. He is a fellow of Indian Society of Agronomy 2013, fellow of Indian Society of Soil Salinity and Water Quality 2016. Dr. Yadav is presently serving as a Vice President of Indian Society of Soil Salinity and Water Quality. He organized second, third and fourth national seminar of the society. ICR CSSI Golden Jubilee International Conference held on 2019. He has done a very good performance in this. He was also associated in organizing 12th Agriculture Science Congress during 2015. So this is the brief biodata of Dr. R.K. Yadav. Please go through Dr. Yadav. Please.
Thank you, Dr. Kripa. Honorable Vice Chancellor, Honorable Professor Tomar sir. Am I audible, sir?
Yes, sir.
Okay.
Yes, sir.
Honorable Vice Chancellor, Honorable Professor B.S. Tomar sir, Honorable DBT sir, and all distinguished dignitaries as well as participants. I shall be discussing in the coming 30 minutes about overview of reclamation and management of salt affected soils, and I have also deliberately added poor quality water in it. So, are we really food secure? This is the importance, how we should move, why should we think of, as Professor V.S. Tomar has already set the context, that though we are sufficient, but in the coming times, with increasing population, decreasing land resources, requirement of our food will be very high, and because of competition from other more paying sectors of the economy, the requirement of these natural resources, particularly water, is going to decrease for agriculture. So we need to think of working or improving the productivity, production, and management of salt affected soil. So as such, we start with the inventories of salt affected soils. India has about 6.73 million hectares of salt affected soils. Out of this, 3.77 million hectare is sodic and 2.96 million hectare is saline. This data is quite old, and we are in the process of upgrading the database, and we have completed for Haryana. We are in the process of completing for UP and Gujarat. So that would combinedly complete almost half of the area of salt affected soils in the country. So that way, by next year, we would be able to give you the updated database of 50% of the area. So at present it is 6.73 million hectare, and it is based on 1995-6 satellite images, and a consensus between NDSS, LUP, CSSRI, and NRSA. This is distribution. This is how this salt affected soils, they are causing loss of around 17 million tons of food grain. And if I account it in terms of monetary loss, it would be more than 23 billion rupees. So it's a huge loss that is incurring because of the low production of salt affected soils in different states of the country. So, considering all these facts, our predecessors in CSSRI and in different state agricultural universities and AICRP, they worked on these problem soils and water, and they have characterized for classification. And if I just read out the PHS of saline soils, if I talk of saline soils, their characters would be salinity, that is the EC would be more than 4 decisiemens, PHS would be less than 8.2, ESP would be less than 15. And here the nature of salts would be mostly neutral, and they would be dominated by chlorides and sulfates of sodium, calcium, and magnesium. But in case of alkali conditions, the PHS would be more than 8.2, ESP would be more than 15, and ECE can be variable depending upon the presence of concentration and composition of the salts. But invariably, these salts would be capable of alkaline hydrolysis and dominated by carbonates and bicarbonates of sodium. So these are the basic characteristics, and based on these, soils have been classified. You can see degree of salinity and sodicity, which is means how we categorize them. If I talk of salinity, then in case of alluvial and heavy soils, it has been differentiated. Slight salinity, 4 to 8 decisiemens. In heavy soils, it is 2 to 4. That means in heavy soils, lower concentration of salts can be as harmful as higher concentration of salts in case of alluvial soils. Likewise, in sodic soils also, this PHS and ESP could be means in case of heavy soils, it would be means lower of these parameters can be more can induce more adverse effects. Where from these salts arise? It could be weathering of minerals, shallow water table which is of poor quality, then flooding and seepage, then there could be impeded drainage conditions. So these could be some of the reasons in case of landlocked areas, but in case of coastal areas, it could be seawater invasion and aerosol movement of the soils. What are the environmental effects? This could be on roads, buildings, crops, and that leads to almost patchy or complete failure of crops and vegetation. In case of alkali soils, it is again, it becomes barren. Physical conditions get deteriorated to that extent that even its working becomes very difficult. If it is wet, then you cannot move in because of unstable structure. But when it is dry, it gets scratched and it becomes so hard that even working becomes very difficult. Alkali soil reclamation. So it started alkali soil reclamation. Here, gypsum was the first and very easy way of reclaiming these soils. You can see for every milliequivalent of sodium, we need 1 milliequivalent of calcium to replace sodium from exchange site, and it should be occupied by calcium. So that way, in general, for 1 milliculant removal of sodium from exchange site, we need around 1.72 tons of gypsum for 15 centimeters of 1 hectare of soil. So that way we can work out how much sodium has to be replaced, and that would give you the requirement of gypsum for reclamation. However, a nomogram has been prepared by CSSRI, and on the basis of, since PHS and ESP are mostly directly and positively related, so for easiness, the gypsum requirement in different textural soils was worked out on the basis of PHS of the soils, and you can see it varies from as low as 2 tons to as high as around 20 or 22 tons, depending upon the PHS and textural class. This textural class is majorly govern the clay percentage and the exchange capacity of the soil. So that way, even lower exchange capacity ESP of heavy textured soils would require more of gypsum to replace the sodium. So that way, by this nomogram, we can roughly estimate. Otherwise, we can work out gypsum requirement as per lab methods also. So with gypsum, so far we have reclaimed around 2.07 million hectares of salt affected soils in different states. You can see with the formation of land reclamation boards in Haryana, UP, Punjab, and even some other agencies in different states, and that way we have reclaimed around 2.07 million hectares, which are contributing more than 16 to 17 million tons of food grain towards the country's basket. And that way it has helped to improve the living standards of more than 16 lakh marginal farmers, 1 lakh small farmers, and around 15,000 big farmers. What are the impacts you can see? As I mentioned, about 2.07 million hectare of alkali land has been reclaimed, and it is contributing around 16 million tons of paddy, wheat, and some other crops. And also, in turn, it is creating around 250 million man days for employment. So now we are facing some problem in availability and quality of gypsum available for agriculture. Gypsum has requirement in other sectors of economy like construction, POP, and other uses. So we are in a situation where we are compelled to use lower grade gypsum. So to overcome these problems, we have started working on elemental sulfur and its combination with calcium chloride or calcium sulfate. So that way the institute has developed some packages which need further testing on a larger scale. Though we have worked in Indore, we have worked in UP, we have worked in Punjab and Haryana and even Rajasthan, and you can see it works. This is in collaboration with the Reliance Industries, and the refineries, they produce sulfur, lot of sulfur, that is waste or byproduct of those refining processes. So that sulfur can be used for reclamation of sodic soils directly. They have we have also worked on sulfur earlier also, but because of the problem of oxidation of sulfur under alkali conditions, it is very difficult. But and its solubilization under alkali conditions. So they have, this Reliance Industry has incorporated some chemicals, some polymers, and that help to get it more dispersible. It disperses quite well, and that way it gets mixed in uniformly, and that helps in its oxidation relatively faster. So that sulfur can directly be used in the soils where in the surface soil amorphous calcium carbonate is more than 2%. So this accounts about 1.98 million hectare in case of Madhya Pradesh, Maharashtra, Telangana, Tamil Nadu, Rajasthan, Andhra Pradesh and Karnataka. But for lower calcium carbonate concentration soils, where we have added calcium in that sulfur, and they have formulated that product, and for even still lower, which has less than 1%, we need to add more than 10% of calcium chloride with sulfur. So that way, in this direction, we are moving to overcome the problem of quality and availability of gypsum. To further augment the oxidation process of sulfur, CSSRI is working on identifying, isolating some of the microbes which can help in improving or fastening the oxidation process of sulfur. So we have identified some 3, and we, in the farmer's field conditions, those are showing some promise. Likewise, other amendments can be used or can be tried, which are municipal solid waste compost as per the government directives or government goals of reducing the waste and recycling it in the smart cities. This municipal solid waste compost, if it is enriched with 25% gypsum, 25% GR of gypsum, it can be very helpful, as effective as gypsum in case of reclamation as well as crop production. Enrichment with elemental sulfur, phosphogypsum also improves nutrient availability and reclamation efficiency. We are also in the process of another source of gypsum can be flue gas desulfurized gypsum. That is a byproduct or a waste product which is obtained from SOx gases which emanates from coal-fired thermal power plants, and they are producing huge amount of this flue gas desulfurized gypsum. We are working on this, and it's being a standard process. Its quality is good. Its calcium sulfate content is better than mined gypsum, but still we have some problems of heavy metals. So we are working on testing the environmental issues, assessing environmental issues, and that way, once we are through the process of assessing this, this can be another alternative. After that, for alternate land uses, where these gets deteriorated and calcium carbonate nodulations, they accumulate at a certain depth in the soil, their application of gypsum or other amendments in the surface soil are less effective. So those areas, those soils can be improved or brought under cultivation by agri-horticulture or agroforestry systems, and for that auger hole technique has been standardized. In this, the auger, the tractor mounted auger is used to pierce through the hard conker layer, and in that gypsum plus sand plus original soil plus some of the nutrients, fertilizers are added, and that way plant can trees or horticultural species can be planted and their establishment and growth can be ensured. So in some of the dryland areas, agroforestry systems like bale, then Amblyca officinalis Amla, and Karonda. These were tried. Also Prosopis alba, a thornless species of Prosopis, which has a good fodder value, that can also be tried, and that was found successful in case of dryland saline conditions with palm millet, mustard, or palm millet, barley or cluster bean, and also aloe. Edible cactus can be one option, which can also be tried under saline conditions, dryland saline conditions. Some practices were standardized in case of heavy textured sodic soils. Other crops like banana and amla, they were also tried, and in continuation to this, under dryland conditions, this Metricaria and basil, they basil as well as this what we call it, भूसी, जिसकी भूसी लेते हैं उसमें वो भी ट्राई किया जा सकता है, and that comes to be very successful. Multi-enterprise diversified farming is another option, as already mentioned by Professor Tomar, that we need to go for diversification of our resources or our cropping systems or our farming systems, so that risk can be reduced. Here, under partially reclaimed sodic soils, we found that this integrated farming system or multi-enterprise diversified farming proved more economical, beneficial in terms of income, profit consistency, employment generation, regular employment generation, regular income, fertilizer use efficiency, irrigation efficiency, means that means all input use efficiency, as well as this greenhouse gases emission potential. So in comparison to the existing rice wheat system in this area of Haryana and Punjab, so the diversification that needs to be optimized, which component should be practiced in how much area, depending upon the resource limitations, we need to optimize, and that is the better option to increase income and employment generation, as well as risk, reducing risk. Then comes the saline soils. In the saline soils, there are different criteria followed by different states, you can see, but as such, whenever water table comes within 1.5 meter, we consider it waterlogged, and if the quality of water table is poor, saline, then it's waterlogged saline soil. So that needs a different approach. Here we started with manual laying of subsurface drainage, but with time, at present, we have the machines, we have the system which automatically digs in one go and places the pipe at desired depth, and that can be this technology can be applied in larger area in a shorter time. That can help in improving the saline waterlogged saline soil reclamation process. This subsurface drainage technology, this is mechanical. This releases or the discharges effluents, and with effluents, some of nutrients are also going. So depending upon the location specific conditions, we need and the requirement of crop root zone, we need to decide the depth as well as interval. Though CSSRI has worked on different guidelines, different criteria and cost estimates for different regions, different types of soil conditions. In this, you can see there is another type of this to reduce the cost, mole drainage for heavy textured soils. So this is another type where no pipe is laid, only mole is made, a cut is made that is made at desired depth, and that can be as effective as pipe subsurface drainage, but with shorter life. Then to control the loss, and once the surface soil or the desired depth of soil is reclaimed from salts, then we can go for controlled drainage conditions. That would reduce the effluent volume and also reduce the loss of nutrients which are going waste and creating problem in surface water bodies. So this is means more scientific at present. The area so far is around, this is 70,000 hectare, not 62. The area so far reclaimed in different states is around 70,000 hectares with this SSD technology. And now we are also trying to bring in or testing a technique for heavy textured soils and for controlling surface water logging. This is a project we are carrying out with Zircas, Japan. In this, a machine is there which cuts the soil. A cut is made, and in that cut, crop residues lying on the surface are placed at the bottom, and the depth varies depending upon the tractor power. It can be from 45 to 60 centimeters, and it is working in the areas where surface waterlogging is a problem, and the infiltration rate or hydraulic conductivity of soil is poor. We are also trying to see its feasibility for improving subsurface sodicity reclamation. And we have done some experiments in Punjab on sodic soils and in Haryana on saline soils. So this could be another sporting technique for SSD. SSD technology, as I said, it improves. Average increase in productivity is around 45% in paddy, around 110% in wheat, and more than 215% in case of cotton. And it has a potential to generate additional employment of 128 man days per hectare per year. Now we move to resource inventories on poor quality water. As far as poor quality water is concerned, though information is again old, and we are in the process with the help of AICRP and CSSRI and other state universities, we are in the process of updating this database. But the present database indicates that from 32 to 84% of groundwater development which is used for irrigation is of poor quality in different states. And out of this, around 20% water is poor, saline, 37% is sodic or has a residual alkalinity, and around 43% has both problems simultaneously. Water quality distribution in some of the states, you can see it varies among different states. In case of Punjab, it is 19. In case of Rajasthan, it is 68. Haryana, 55. Uttar Pradesh, 53. And that way, different states have different proportions or percentage of poor quality water. Madhya Pradesh has around 15. distribution between saline sodic and saline sodic in different states varies again. So what are the criteria on the basis of which we can classify, as we classified salt affected soils into saline sodic and saline sodic? Here also there are criteria, similar criteria: electrical conductance, residual sodium concentration, sodium adsorption ratio, and some specific elements like boron, chloride, and sodium. As you all know, EC is an indirect measure of total dissolved salts, and it affects probe production through osmotic potential, which reduces water uptake of probes, and along with water, it interferes in uptake of nutrients, and also has some adverse impact on certain essential nutrient uptake. Then comes residual sodium carbonate, which is the difference of carbonates plus carbonates minus calcium plus magnesium. And if it is less than 1.25, EC should be less than 2 for normal water. Or I'll give you the criteria and guidelines. And then sodium adsorption ratio, it is the proportion of sodium in comparison to calcium plus magnesium. These are the conditions for good quality: saline, marginally saline, saline, high SAR saline, alkali water, marginally alkali, highly alkali. How these have chemical impacts on the soil? That is, the sodic water induced sodicity or adverse impacts on soils. Then SAR is one factor. This SAR leads to development of ESR, exchangeable sodium ratio, which can be calculated by this Kg selectivity coefficient into SAR of irrigation water. That gives ESR in the soil, and that ESR can be used with this equation to calculate how much ESP is likely to develop with use of a specific SAR water. But see, in case of when we go for irrigation, and in between two irrigations there is drying of water, and that way calcium and magnesium may precipitate, and there could be higher estimate of higher level of SAR development in the soil solution, and that may have more adverse effect than what we are calculating with SAR. So then came the concept of adjusted SAR, and here with this equation we can work out adjusted SAR by this, and this PHC is the pH of the irrigation water, or when it is in continuous contact with lime and in equilibrium with partial pressure of carbon dioxide. So that pH is the PHC. So that way we can find out adjusted SAR and then ESP. But it also sometimes it is also found that since in this carbonates, bicarbonates are never considered, so the concept of RSC came into being, but still all these have been found to overestimate or sometimes underestimate. Then came the concept of adjusted R and A. Here, except calcium, in case of SAR, here calcium X is taken into account, and that represents the modified concentration of calcium due to ionic strength and its proportion in relation to bicarbonate. So that way it gives relatively more accurate picture which is likely to develop into the soil solution. Later, Minhas and Sharma, to O.P. Sharma ji, in 2006, they, based on large number of long-term experiments, they came up with another equation which can be used to predict the possible ESP which is likely to develop. This is, they introduced the concept of depth of sodic irrigation water used in the for crop, then whatever was the rainfall, and what is the ET demand of the crops grown in sequence. That could lead to, means they found that is giving a very good correlation with observed values of up to around 0.7 R square. These are some of the more specific ions which have been means worked or standardized for taking care before recommending use of such quality water for irrigation. Among specific ions, calcium should be more than 35 always, and sodium should be less than 65% of total cations. Calcium magnesium ratio also plays a big role. Honorable DDG has done some good work here at CSSRI also, and earlier works also, they indicate that calcium to magnesium ratio should be more than 3. Sometimes silica also plays a role in creating a problem of physical conditions. Boron toxicity starts at 5 ppm, lithium 0.5 ppm, chloride more than 5 milliequivalent, while chloride to sulfate ratio, if it is more than 1:3, it also proves injurious to fruits. Likewise, iron, fluoride, molybdenum, and aluminium also become toxic to crops at 1.05 and 5 ppm respectively. So these are the guidelines based on the experience gained. What could be these possible guidelines in general, but we need to further refine them as per conditions. See, in case of in this, soil texture is accounted, rainfall is accounted, and crop tolerance is accounted, and that way you can see if soil is fine, then limits of use of saline water are lower in comparison to the areas where the soils are coarser or rainfall is higher. So you can see, in case of fine textured soils where crops are sensitive and rainfall is around or less than 350 mm, even 1 decisiemens salinity of irrigation water becomes critical, upper limit, and it may increase or it can be as high as 12.5 when the soils are coarse, where clay percentage is less than 10, crop is tolerant, and rainfall is around 600 mm, that is 550 to 750 mm. So that way crops, their tolerance, textural class of soil, and rainfall, those govern the conditions, and these are the guidelines. For alkali waters, residual alkalinity, again, the amount of water used, amount of rainfall, and fineness of soil, clay percentage of soil, that govern the limit which becomes safe or critical for use under different situations. In case of fine soils where clay percentage is 30%, RSC of around 2.5 and SAR 10 becomes limiting even when Kharif is fallow followed by any rabi crop. But in case of moderately soils, we can use even up to 5 milliequivalent of RSC water with SAR10 and where rainfall is more than 550 mm. Likewise, these are the guidelines which indicate the critical conditions or limits based on soil type, rainfall, and then crop. Management of poor quality water. Here you can see the saline water can be used with in different modes like mixed mode, cyclic use in different seasons, cyclic use based upon sensitivity of crop stage, and as far as alkali water is concerned, the residual alkalinity of water can be neutralized by passing the water through gypsum or pyrite beds, and then its use either directly into the water used through every irrigation. That means water is neutralized in every irrigation. But if such situation is not, means farmer cannot adopt this, then based on the requirement of irrigation water, its composition with respect to residual alkalinity, we can estimate how much gypsum or pyrite is required. Basically, gypsum is more commonly used, can be applied to the soil before planting crop. But the effects varied in its use. It is clear that gypsum is required to neutralize RSC, but in case of saline sodic water, high levels of ECE, pH and SARE together combinedly affect the plant growth, and all these need to be considered simultaneously for determining the response of applied gypsum. Better option is to neutralize it with every irrigation through gypsum beds, but sometimes it doesn't happen, so it can be used before planting crops. But when higher RSC is there in water, then again neutralization with irrigation becomes more useful. I don't know about Madhya Pradesh or that region, but in Punjab, Haryana, we are facing the problem of availability, which is again a ground gypsum is used, and the passage of water through the bed of ground gypsum becomes very difficult. So we worked on another addition, and we tried gypsum plus press mud in 4:1 ratio, volume by volume in beds, and that is found as effective as in reclamation, in neutralization of RSC, as effective as gypsum, and with improved passage of water. So this can be used when ground gypsum is available for gypsum beds. See, another factor could be waterlogging, water stagnation, and CSSRI has worked on recharge structures to avoid waterlogging and to add more of rainwater or canal water into the groundwater, and that way dilute the concentration of salts in the groundwater that can be used later at later stage when required. So this recharge structure is working well. Biodrainage can be one option which has been tried again by Honorable DDG and Dr. Dagar Saab in Haryana in Puthi area, and there we found that eucalypt, when planted in paired rows on the acre boundaries, planted at 1 by 1 meter, can help in reducing or depleting water table by around 40 centimeters per year. So that is another option for drainage. Laser leveling is another option which has been tried, and it has been found that it saves around 30% water and improves yield by around 15 to 20%. So that way, if we add less water, we will add less of salts. This is different ways of installing these recharge structures. Then another option of management of such poor conditions or marginal conditions, salt affected conditions, is development of salt tolerant cultivars, varieties of suitable crops. CSSRI as such has developed 9 rice varieties, 5 wheat varieties, and 5 mustard varieties, in addition to 1 chickpea variety and 2 susbania varieties. And that way we are means if farmers are not able to go for SSD or gypsum application at once, they can go for these tolerant varieties, and that way they can get satisfactory yields from their fields. Impact as such, this is not updated. The updated version indicates that only one variety of rice, that is basmati type rice, CSR 30, the APEDA data indicates that it has generated around 24,000 crore rupees of foreign revenue by its exports. So such system can be, such varieties, if they are very useful, they can be very helpful in improving livelihood security as well as those improve the exports. Then comes, I will not go in detail for the coastal areas because Dr. Burman might be dealing it with, but just to give you the glimpse of overview, the institute and its center, coastal center at Canning Town, they worked on land modifications, and in that, in lower areas, paddy cum fish is taken, in the middle areas, rice is taken, and in the upper areas, they trade it into 3 elevated layers, and in the lowest it is fish, followed by middle rice, and then in the upper vegetables can be cultivated, and those have become successful, and that is a very useful technique to utilize the situations where water is plenty during rainy season, but it is not available during winter season. Then waterlogged sodic soils. In Sharda Sayak area, you can see it is very huge area in Uttar Pradesh, and there again land modification with pond and on dikes, the farmers are taking. There, what is the problem? The surface soil sodicity is higher, lower area, lower depth soil is less sodic. So when we invert it, means when we dig pond, the lower depth is comes up on the upper surface on the dikes, and on the dikes the crops can be taken, suitable crops, even horticultural crops, and in the pond fish is taken. And the net returns from this system, where the farmer was not getting anything, was around 45,000 rupees with a BC ratio of around 3. So such options have been standardized. Those can be used for manipulating such marginal conditions. Again, root zone with microbes, microbial formulations. Our Lucknow Center has worked on development of certain microbes and microbial consortia, CSR Bio, Fusicont, and those have been found very helpful under sodic situations in controlling wilt, in improving the performance of crops, specifically banana and other crops also. It has been tested, and this has been commercialized also. It is a consortium of different microbes, bacteria and trichoderma. This is CSR Bio, and 3 firms have already got the agreement, and they have already supplied the material on more than around 750 means 1120 hectare, and that way such options should also be tried. Then we are also working at present on screening of salt tolerant root stocks and sign of guava, bale, date, jamun, pomegranate, and low chill requiring semi-tropical fruits. And in case of guava for sodicity, in case of bale and pomegranate, we have screened some root stocks as well as sign for around pH 9.63 for guava, and for other crops, 3 crops for saline conditions. As far as saline black soils are concerned, these are around 1 million hectare, and you know better than me, Dr. Verma, Dr. Bangar, they will be dealing, I think, with this, so I will not take more time on this. This is the area in different states. So this is all. In conclusion, I can say that such soils, such resources, I would say, salt affected resources, can be managed, reclaimed to good extent to improve the farmers' income and their livelihood. Thank you very much, sir. Hello.
Hello. Thank you very much, sir. Thank you very much, sir. Hi, Yadav, sir. Hello.
Sir.
Sir, thank you very much.
Thank you, sir. Thank you.
Thank you very much, Dr. Yadav. Thank you very much. You are very, yes. Any queries, sir?
Thank you, sir. Thank you very much.
Any query? No. Sir, thank you very much, Dr. Yadav. You have very well mentioned that classification of soils and mentioned what is the area of extent of salt affected soils in India and how much gypsum is required for the reclamation of salt affected soils. And you have mentioned so many things, particularly in elemental sulfur, which is a new product for the development of developed for the site specific reclamation. Very important, sir. And on the basis of this water quality criteria that is has been given by you, EC, SAR, and on the basis of RSC, and more specific is that the calcium magnesium ratio that is greater than 2 for the deterioration of the soil physical part. This is an important thing, sir. On the basis of this other element, that is fluoride 1 ppm, molybdenum 0.5 ppm, as well as the aluminum 5 ppm, that is very toxic for the crop. Thank you very much, sir. Thank you very much, sir. May I request Dr. Burman? Dr. Burman, please. Dr. Burman, before calling Dr. Burman, I would like to give this brief biodata of Dr. Burman. Dr. Burman, born the 6th November 1966. Presently, he is holding the position of head and principal scientist in discipline of soil science at ICR, Central Soil Sanitary Research Institute, Regional Research Station, Canning Town, West Bengal. He has also received a PhD degree in agriculture physics from IARI and this after 1995 he has been engaged in research at various scientific positions in ICR institutes. Example, IGFRI and CSSRI on sustainable management of problem soils in semi-arid and coastal region of augmenting agricultural production. He is having 18 years of research experience on soil and water management for agricultural development in coastal salt affected region. He has developed many technologies especially for small and marginal farmers of this salt affected coastal region. During his research career, he has handled many in-house research projects and international projects funded by GEF, CGIA, CBWF, UNGF, IRI, IRRI, and ACIAR as a principal investigator as well as the co-principal investigator. As far as the award is concerned, he received Jawaharlal Nehru Award of ICR, Young Scientist Award of Indian Science Congress Association, and he was also awarded as a Fellow of Indian Society of Coastal Agriculture Research. He has several publications, national and international journals. So I invite Dr. Burman on the topic of the coastal salinity management in India. Dr. Burman, please.
Thank you, Dr. Wanger. Honorable Vice Chancellor, Honorable DDG NRM, and other dignitaries present today, Dr. Jadhav, Dr. Kalai Dhankar, and ladies and gentlemen, and particularly the students. So I'll be talking on the coastal salinity management in India. You know, the coastal zone is quite different. It's very fragile. It's a risk-prone area where agriculture and aquaculture coexist and supports the livelihood of the many people who are living in the coastal areas. So around 14.2% of the people lives in the coastal area. We have the 9 coastal states and 3 union territories covering 7 districts. Out of 7 districts, 66 is in inland condition and 3 in Andaman and 1 is Lakshadweep. We have very long coastline, around 7,500 kilometers in India, and it covers around 10.8 million hectares. And you see the entire coastal agroecosystems covers under 4 agroecological regions. One is the eastern coastal plains, here in the 18 zone, and western Ghats and coastal plains. There's a 19-1, this portion, and western plains, Kutch, and part of the Kathiawar Peninsula, this 2 and 5 also, in some Gujarat covers Gujarat, and another is the island of Andaman Nicobar and Lakshadweep. These are the 5 agroecological regions are found in the coastal agroecosystem. Now the coastal lands are subjected to various processes of land degradations. There may be different causes. Immediate causes may be biophysical causes, that is steep slopes, high rainfall, poor natural drainage, maybe natural calamities like cyclones, tsunami, floods, and sea level rise, and unsuitable land management, unsustainable land management practice also another of the causes of the land degradations. And these are the different maybe deforestation, unscientific use of the coastal lands causing the degradations, and underlying causes also causing the degradation of the coastal lands, maybe population density, poverty, land tenure, and access to agriculture extension infrastructure. And policies also sometimes promotes the land use of the land degradation practices. These are the different causes of land degradation inside, but the main process of land degradation in the coastal area is the water erosion, salt accumulation, acidification, and the waterlogging. Now I'll be talking about the different degradation processes. If you see the coastal zone, that is agroecological region 18, 19 and 20, we can classify the different degraded soils of the coastal region, maybe due to erosion, forest, due to acidity, and waterlogging, excessive salt. So it comes around 18 million hectare under 3 agroecological regions. Now, what is the major process of the coastal salinization? This is the main process of the land degradation in the coastal region. One of the reasons is the flooding with the saline water or the seepage from the rivers carrying the high saline water. This is one of the reasons. And another is the concentration of the building of the surface salt and surface due to evaporation. You know, the coastal area, the saline, the aquifer is very nearer to surface, and through evaporation it comes onto the salts comes to the surface. This is the one of the process. If you see that total coast salt affected area in the already Dr. Jadhav also informed that it's 6.73 million hectare, and out of that 1.2 billion hectare is under coastal saline zone. It covers it at around 18.6% of the total salt affected area of the country. Now this soil salinity is very dynamic in nature. It's just during the monsoon or Kharif season, it comes very down. This red color one comes to almost normal situations, but after monsoon, it rises and it goes to the maximum during the month of April or May. And if you see the water logging here, the Kharif season water logging is very high, and due to high rainfall, the leaching of the salts become almost saline. But during the Kharif season, coastal area, most particularly the humid region, the salinity is not much the problem unless there is no inundation of the saline water in the agricultural land. There, the water logging is a problem, but if you come to the Rabi season, here the salinity is the major concern for the agriculture productivity. We see the distribution of the coastal salt affected soil in its characteristic. We can classify it, you can divide into different major classes like saline marsh of the Rana of Kutch, where the rainfall is less than 300 millimeter, is very less rainfall zone area, and where soil is neutral to slightly alkaline pH, high EC, and other problems of the ions there. And another is the 7,700 to 900 millimeter zone, where the medium to black soils of the delta coastal semi-arid region, it comes to the Gujarat and Andhra Pradesh and Telangana also. Another is the deep black soils, where neutral to alkaline soil pH and high EC, and correspondence with the chloride and sulfates, where it comes under the distribution if find is around Andhra Pradesh, Gujarat, and Karnataka. And saline micaceous deltaic alluvial of humid region, where rainfall is slightly very high, that's 400 to 600. You will find this type of soil in Sundarban Delta, the coastal zone of West Bengal, and the Odisha also. He has pH of the soil is neutral. Sometimes it's a slightly to highly acidic pH. We will find the acid sulfate soil in this high EC of the others, another constant for this type of soil. And another is the high rainfall area, where 2,100 to 300 millimeter rainfall is occurred, saline, humid, and acid sulfates of the humid tropical region, where high acidity is will find in the soil, and high EC also, and presence of the humic horide and the dynamic sulfide chloride soil, mostly in the Kerala and the Malabar coast of the Kerala and West Bengal, in particular Sundarban region. And this is typical characteristics of the coastal soils, saline soil and acidity. If we compare both the soils, the saline soil is not much pH, is not the constant for the agriculture productivity, it's almost in the neutral range. But in the acid sulfate soil, both the acidity as well the salinity sometimes it goes to very high, 43 or all. Something like that, and organic carbon content is varying in both the cases. Sometimes we find the more organic carbon in the acid sulfate soil. CEC is also very high here, ESP and other ranges. If you'll find these are the major soils covering the coastal area, saline soils and acid sulfate soil. And other than that, natural process of or other natural calamities causing the salinity of the degradation through salinization of the soil of the coastal region. Another anthroponic activity is very, very concerned for us, that is the brackish water farming in the coastal region. And due to the farming, the agricultural land is now slowly converting the stream, very rapidly, and I can't say very rapidly, because the stream ponds, because stream cultivation or brackish water aquaculture is more lucrative than the conventional agriculture practices and the very constrained environment where the problem of salinity and waterlogging in the coastal area. And it causes, due to practice of the brackish water, is causing the salinization of the soil and water in the adjoining area, and more land is now converting the salinization. And this is the major concern for the means a bad effect or the impact of the brackish water aquaculture, which causing the salinization and more degradation of the coastal land to salinization. Moreover, the different chemicals or the foods are using in the brackish water farm. Sometimes they also cause the chemical pollution in the coastal region. And if you see that this is the brackish water farm where the agricultural land is converted to brackish water farming, but adjoining area, if you see that there is the paddy, due to seepage of the water from the brackish water farm, its paddy or nearby agriculture crop is now deteriorating. Now the farmers in the adjoining area, they have no options to give the land on lease basis to the big farmers or big owner for the brackish water, or they don't have, or they are bound to convert their agriculture land to the brackish water farming. This is type of impact of the brackish water, adverse impact of brackish water on salinization development or degradation of the coastal lands. Along with that, another climatic hazards. You know that coastal regions mostly is very, very vulnerable to exposed to the different cyclonic storm, and both the eastern and western coast. But if you see that eastern coast, the data, cyclonic data from the long data 1819 to 2018, it shows that Bay of Bengal is having, though it's more cyclonic storm has been created on the Bay of Bengal, 520 compared to the Arabian Sea, the western coast. So eastern coast is more vulnerable to cyclone rather than the western coast. But due to that cyclonic storm, that is causing the degradation in terms of the waterlogging, storm surge, and seawater into inundation of the agriculture. Large agriculture is happening on a regular basis in the coastal region. So this is one of the process of degradation through the climatic hazards or the climatic cyclones to the salinization or degradation of the coastal region. Now we have studied some of the vulnerability of the coastal region, particularly Sundarban area. We are walking very near to Sundarban. It's very, it's a very important area. It's a World Heritage Site, and it's very vulnerable area. We have seen, as an example, I'm showing here, and we have seen that many villages of the coastal area is very, very vulnerable to climate change. If you see, out of say 1,074 and 139 villages is very, very vulnerable. But when we are analyzing for the risks to agriculture, considering the different function of the vulnerability, hazards, and exposure, its situation is quite alarming. More number of villages or the people of the farmers of that area is more vulnerable to their agriculture practices is very rich due to climatic change. Now, another reason is that, you have already very debatable issues and a very well discussed topic, the sea level rise, and the coastal area is very, very vulnerable to sea level rise. But these are the red zone. This indicated that these are the very, very vulnerable to coastal sea level rises. But the impact of the sea level rise is not uniform along the east and western coast. It depends on the many characteristics of the coast, maybe geomorphology, slope, and the other factors of the tide and how that tide is coming as a wave and all these things. That is also things that we have analyzed. The sea level rise is framed in the coastal area based on the permanent service for the mean level database. We have used that one database, and we have seen that Sundarban is a very, very very sea level rise is very alarming compared to the east coast and west coast. This is one of the Diamond Harbour. This is the Diamond Harbour station. This is very near to Sundarban. If you see, there's the long-term data shows that 1948 there is increasing trend of sea level rise. We have also studied the decadal changes. West Bengal, eastern coast is more decay. They are changing. Means sea level rising is more compared to the western coast. This is due to sea level rise. We expect that more area will be inundated, more salinization will be there. So if you combine all these factors to agriculture productivity, and what are the constant? If you see that this is the degraded land and water with the high salinity and water logging and drainage condition. I already told due to different processes, whether at first it is the flooding and erosion with the seawater is another major constants for the agriculture productivity. Coastal and high scarcity of the irrigation water in the dry season. Yes, then we have received particularly humid traffic in the coastal region. It's a very high rainfall during the Kharif season or monsoon season, and sometimes it's a problem for the people due to flooding and waterlogging. But if you come to the dry season, there's scarcity of irrigation water. Fresh quality of irrigation is a major constraint for the agriculture. So, and poor health, soil health, and unscientific soil fertility management is also another constraints for the agriculture production in the coastal area, and a lack of knowledge and less accessibility inputs to infrastructure. Very, very important aspect. The people who are living very remote area are not accessible to the inputs and other infrastructure. So their agriculture having the problems, the farmers of that area having the problems of the wind. So let's see the different management options of the degraded coastal, particularly soil affected lands. Already Dr. Jadhav told that amendments which will be used for the non-saline soil. Just I have given some example. He have discussed those amendments can be used the non-saline sodic soil. Particularly sodic soil, you can go for this type of amendments, gypsum and other maybe distilleries, paintbrush, and these are the amendments can be used. And another soil that the acid sulfur soil already mentioned, that the soils are having both the problem acidity and the salinity. But acidity or the salinity is a problem when the soil is under arable condition. The soils is forming under through the alluvial found in the alluvial joint patches in the West Bengal, and also Kerala. And the pyrite is a major problem for the acidity developed during aeration. Then the oxidation of the pyrite creates acid, sulfuric acid that cause the acidity in that area. So we have to remove by leaching of this soil, and otherwise we can maintain a high water table so that it can be the aeration can be stopped, so oxidation of the pyrite can be stopped. By that way we can go for some management options for the but we can go for the lime and as a amendment for this acid sulfate soil. And you know, this sulfate soil is very toxic to iron and aluminium, and it has a very high fixation capacity of the phosphorus fertilizer. So in that case, we need to have the higher doses of phosphorus, and the split doses of phosphorus need to be applied rather than special one-time application, because the oxidation capacity of the soil is very, very high for the phosphorus. We can go for the rock phosphate as a cheap source of phosphorus, and sometimes the oyster cell is plenty available in the coastal region as a liming material that can be used for that amelioration of the acid solid soil. And for the nutrient management practices compared to the inland area, we need to have some different practices for the coastal situations. And fertilizer containing chloride and sulfate may be avoided. Ammonium fertilizers, very, very particularly just under saline conditions, is very volatilized. You know, around 30 to 50% loss is there. Ammonia loss through volatilization. So we must go for the deep placement of the fertilizer or the slow release nitrogenous fertilizer. This type can be used. And so we found that through the long-term experiment, the soils are very rich in potassium. So sometimes we need not to apply we can avoid the potassium fertilizer application in the soils, but we need to apply the phosphorus in the saline soil to maintain the fertility. Sometimes the soils are mostly in different ranges. We have found in Indian coastal soil sometimes low in phosphorus, some medium, some zones, some areas in India, and sometimes phosphorus, high in phosphorus content also. So based on the soil fertility status, we need to apply those and already and some so placement is very important. It should not be very nearer to seed, and so it causes more salinity in the application. Organic manure definitely in combination irrigation, when integrated fertilizer application is more advisable for this coastal soil salinity management. Along with that soil management, we must have to stress tolerant crop and their crop varieties like this. I just mentioned here the rice crop, which rice is a major crop in the coastal regions. So nowadays the SAV1 gene has been isolated from the Indian race FR13 and introduced some of the mega varieties, Sarna SAV1, IR64 SAV1 and other varieties also, and very successful in this type of SAV1 introduced rice variety for the coastal area, because in particular the Kharif season, if there is a flash flood condition is there, this type of varieties can withstand, or after the retrieve of the flooded water, it can again it can revive and we can expect the better yield compared to the traditional variety or high yielding variety without SAV1 genes. And now Saltol also Cutel also derived from the Pokali, and now it has introduced some of the varieties. Is very now is very advisable for the farmers for the high saline zone, particularly Rabi season, or if there is ingress of the saline water in the coastal region, coastal agriculture land. And sometimes we should have the both dual stress tolerant rice, particularly SAV1 as well as Saltol. Now the work is going on that variety, Sarna SAV1, Saltol, and some mega varieties of IS. Both the genes has been introduced. So this type of, while choosing the varieties for the coastal regions, we must have to choose this type of stress tolerant varieties, not only the rice, the other crop also. This is the one in the picture. If you see just after submergence of the Sarna SAV1, it looks like that it's a crop probably almost failure. But after 3 months after submergence, you see there is now again the crop has come up is a very good, and the farmers got the very good yield from that. This is the characteristics of the SAV1 gene, and it can withstand around 17 days of complete submergence in that. So this type of varieties is required for the coastal area, and already farmers have adopted the area, particularly flash flood areas in the coastal region. And along with that variety, we must have the very specific nutrient management practice, that is because to get the maximum yield from the stress tolerant rice variety, must have the drainage condition, proper nutrient management, and disease pest management. This also is to keep in mind. And now that this one example I'll show you, the intensification, particularly the small and marginal farmers in the coastal region, they're resourceful farmers. So how to mostly, that coastal area is rice is grown, is monocrop area. Those are having the water resources, they are going for the second crop, but mostly it's a monocrop area, a rice growing area. So we have introduced the vegetable crops in a sack filled with soil. In the Kharif season, in altered condition, with introducing the vegetables, and we found that the income can be generated, and there is no adverse effect on the rice crop, because initially around it should be grown early, and after transplanting of the rice, just before the flowering stage, it should be removed for that from the surface, so there is no adverse effect. So this type of small modification, the introduction of the this type of vegetables in the soil, we can enhance the income of the farmers of the salt affected coastal region, particularly Kharif season and other season also. And zero tillage potato cultivations also very very simple technology. Just 15 to 30 centimeter paddy straw has been used for the mulch. No tillage is required. With this tillage practice, zero tillage potato cultivation, we can go means increase our income for the farmers, and not only the income also, and we can go for the another crop. When 3 crops can be taken after rice, then potato, then we can go for the major green crop and onion and other. So we can increase the intensity of the crop around up to 3%. It's very popular in the coastal areas now. The people are going. It's very easy to harvest, and cost of cultivation is very less compared to this is 1.86 to 2.42 base year compared to conventional practice where BCL value is 1.3 to 1.45. Along with that, different crop varieties, we need to have the crop diversified crops, salt tolerant crops, and crop variety. We need to have some to stop the degradation from the salinity. We can go for the shelter beds, casuarina and other crops are very popular. That should be practiced and already being practiced in the different coastal area. This is management work, and where the salinity is very high, we can go for the Salvadora, Salicornia, unconventional crop species rather than the conventional agriculture crops. Now, I'll be talking about the controlling seawater intrusion and drainage important. That is very important for the management of the coastal salinity is concerned. You know that the embankment, particularly in the coastal area, is a lifeline for the people of those people or the farmers living in the coastal area. But maintenance is, we require continuous maintenance of the existing embankment. See, this is the picture where the geotextile material is used. Sometimes grass has been put in that, so that maintenance, different modern tools has been, technology has been developed for the maintenance of the existing embankment. That should be required for, so that we should in that during the cyclonic storm or during monsoons, the water should not, there should not be breakage or there of the embankment, so water should not be entering the agriculture thing. And the rising of the embankment height is also very important aspect, because the sea level rise, the tidal height is now increasing in different areas. So based on the study of the tidal, I need to raise the embankment height, very important. And the embankment is very subject to erosion, and particularly Sundarban area, you know, around 3,500 kilometer embankment was established when during the British period, and it's a very long length of the embankment area. And this embankment is now many areas is subject to erosion. The experts, the hydrologists, they have suggested the systemic retreat of the selected embankments from the tidal channels, very important to protect the people of the agricultural land from the further impact of the climate change from seawater intrusion, all these things. That is required. And we should drainage, definitely drainage is required, particularly in the Kharif season. We need to have the drainage and desiltation of the drainage channel. One of the aspects where many drainage channel is in the course of time desiltation has been occurred, and if we go for that, we should go for the desiltation, so the drainage should be improved. Otherwise, cannot go for the different varieties or the high-yielding variety, or we cannot go for the better management agriculture production. So another is the tidal basin or field management in tidal rivers. One of the aspects for the drainage improvement. This is the very important aspect of suggested by the hydrologist in the coastal area, and proper maintenance of sluice gate and connecting internet canal network. You know, the coastal is very common. All canals are interlinked. So we need to have the very sluice gate. Sometimes one by sluice gate was suggested for this type of car, so that during the high tide, water should not enter, saline water should not enter into the field, and during the high monsoon, if there is a more water logging in the main rainfall, so it drain, it will go to the sea. through one-way sluice gate. This type of management or technology we should. So desiltation of the drainage channel I was talking about, we have worked on that area, the Sundarban area. Initially, so that due to desiltation, it's creating a lot of problem, flooding and all these things. Now we have re-excavated the through desiltation this drainage channel. Now after that re-excavation, that this is working as a drainage channel during the monsoon, and during the monsoon we are harvesting the water, rainwater, so that can be used for the farmers adjoining area, they are using for the farmer. So this type of modification or this management was a very well known practices, but need to have the wider. So now the government of different state departments, they are working on that. They got, particularly, I give you an example, West Bengal got huge amount of money from the World Bank, and now they have started the process of re-excavation through desiltation process in this way. So in this way we can improve the drainage condition, otherwise we cannot go for the better agriculture development. Like the surface drainage is very important, like desiltation of that. We sometimes need to have the drainage network so that we can connect through survey, we can make the drainage network, and ultimately that means drainage water can be put into the river system of the sea, so that the water can be saved. One example of the Andaman Nicobar Islands, we work on there with the Coastal Island Agriculture Research Institute in collaboration, and where earlier there is no drainage problem. The tsunami, after tsunami, the entire area was very serious line, but we have put the drainage network improvement of the layout, drainage. We have got the surveys, then drainage channel has been put. See, after they see now that the drainage has been improved clear, and now the farmers are not taking the many crops, maybe one or two or three crops in that area. So this type of management of production. Another is very innovative degraded management practice of the culture, the land saving. Already Dr. Jadhav has mentioned that. I will tell you the details. Some of the models that we have developed further in the coastal area and implemented large area in the coastal regions. And this is the challenge we try to overcome, like the land degradation, drainage condition, and scarcity of fresh water. The farm condition, how we can create this freshwater resources for the farmers, and how to reduce the drainage conditions and land degradation through this land modification or land saving techniques, that we can address that one. And it's not only that, it's provide scope for the increase the productive potential of the degraded land, and it also we can go for the multiple and diversified crops, and it's very sustainable management practices for the coastal region. So these are the models I will show you. The farm pond models, the different measurement is there. Say how much is the farm pond to be under the dike condition. This is the schematic diagram. This is a monocrop rice crop. Now is converted in the see. This is the Rabi season where multiple crops, along with the integrated farming, there fish is there, rice is there, vegetables, even different crops they are growing. So that through this type of technology, another is the modified farm pond in the broad dikes. That just dike has been widened so that more vegetables and other crops can be taken. Actually, in the uplands, on the periphery and the highland situation, farmers are growing the high-yielding crops throughout the year, and the pond is used for the growing for rice, means for fish also, as well as harvesting the water. And now the land is converted to the medium land for the cultivation of the high-yielding variety, and original lowland is using for paddy fish cultivation. So another is the deep furrow and high risk conditions. This is the different level. 50% land has been converted to region forest systems, and this schematic diagram of that, you see there's a picture of the Kharif season where the bitter gourd was grown along the ridges, and this is the Rabi season tomato has been grown in the condition. And in this channel, the water was harvested in that, and along with the fish was grown. So this is the opportunity of increase the income of the farmers. The paddy fish cultivation, where this is the layout of this a schematic diagram of that where fish and rice and the vegetables can be grown throughout the year. And this is the modified one. Another is the broadbed and furrow system. We have, this is very, very popular in the Andaman Nicobar Islands. Where the land has been modified like this. This is the, after implementation, this is a scenario where different crops, fish, and integration cultivation can be possible. Even the three-tier system, either raised bed, medium bed, and the pond is even exploited for storing the water, and different lands, raised bed or medium land, different means can be used for growing the different crops. Three-tier system. The paired bed technology, this is another land modification techniques for the growing of the different crops, vegetables, fish, and all these things. So even that, along with that, we have the area in the coastal areas very, very saline, very nearer to river systems or in the sea surface, where nearer to sea, where the agriculture may not be possible due to high salinity. There we can go for the brackish water aquaculture. We can go for the this type of pond body. We can excavate the pond like that. We have worked with the SIVA, Central Institute of Brackish Water Aquaculture, and introduced this type of brackish water aquaculture pond. So in that area where the farmers are not getting anything, now they are getting huge amount of money by growing the brackish water aquaculture in that area. The main concept of the land modification is that we are storing the fresh water here and enriching the land from the surface. So there we are restricting the upward movement of brackish water aquaculture, brackish water from the underground due to as the soils are saturated with the fat soil, that is not allowing the brackish water to come to the surface. And when we are putting the fresh water on the surface and covering the soils with the different crops throughout the year, so practically we are managing the salinity. We are reducing the salinity of the system. After 1 or 2 years of cultivation or after of this land variation, we found the salinity is almost neutral, has gone to the neutral range. So and along with that, we are harvesting the water, so that water using for the irrigation is very easy to use in this land modification systems, and fish is growing. So multiple crops, diversified crops are growing, along the fish is growing. So income has been generated in many folds by application, and it's very climatically sustainable technology. I'll show you some of the database where we have studied the water footprint and water productivity of that different system, land modification system, and we compare with the rice monocrop and rice system. If you see that water productivity is very high, but less water footprint of the land modification technique, it indicates that it's not only economically viable, it's a climatically climate resilient technology. We have studied the greenhouse gas emission from the different land modification techniques. If you see that compared to the rice system or rice monocrop system, this land modification greenhouse gas emission is very, very less, though the mangrove system definitely is greenhouse gas emission is very less compared to the agriculture practice. But others, if you see the traditional practice of rice monocrop, rice system, this land modification is very, very climatically resilient systems because we are getting very less greenhouse emission from the surface. So this we have implemented this landscaping techniques in a wide area and a pilot basis and 400-hectare area in Sundarban, a very degraded land in Sundarban and tsunami affected area in the Andaman Nicobar Islands, and around 200 numbers of farmers they've implemented this type of technology. You see that after implementation, that their net income has been increased from 10,000 to 20,000 to 1,70,000. Sometimes it is more than 2 lakhs, around 2.5 lakhs. So this much income we can generate, and due to harvesting of the rainwater, we can we brought the many area under irrigation where no crops are grown during the Rabi season, and we can reduce the salinity 40 to 60%. That brackish water aquaculture I was talking about. We introduced that pond technology, and that farmers is getting around 1.4 5 lakhs, where earlier they're not getting. This is a beautiful example of the land modification. The kharifs in the farmers are growing many crops here, vegetables in there. It's a multiple crop they are going along the piece, but along with that landscaping technique, where the farmers are not adopted, only they're growing the rice crop. You can, by the picture, you can see the changes how to land modification have means important impact on the agriculture production systems. So we have some of the modified the land technology for the growing of the vegetable, agroforestry system. You know, the waterlogging condition, particularly humid coastal region. Around 50 centimeter waterlogging will be there in the Kharif season. We cannot go for any tree plantation. So we have modified land. Around 50% land has been raised it's a region furrow system where this small trench has been excavated and use that soil for raising the land. Here the burnt or embankment has been used. I will show you the picture. So see that after during the Kharif season, we can the trees can be grown on the burnt, and the channel we have excavated for the raising the lands. Water can be harvested here, and paddy can be grown in between the area, and fish along with that other agriculture crops you can grow. In the Rabi season, the trenches, so we can go for the rice with the harvested rainwater, which we have already stored in that area. Along with that, this type of in between the tree rows, we can grow for the low water requiring crop, so that we can diversify it. We can increase the diversification of this type of land modifications techniques, and it's very, very effective for the coastal region, keeping in view the constants of like salinity as well as the waterlogging conditions. I was talking about the degradation of the land, salinization of land, the brackish water aquaculture. So we have worked on that, and we have some techniques we have developed by using that. We need to have the embankment, a plastic lining here, and outside we also make it trenches then. So we have seen that with that we can restrict the seepage. See, this is the one from the embankment where the treatment or channel or plastic plus channel was used, and with the distance the salinity has been reduced. So seepage can be restricted, so that adjoining area where the farmers are growing the agriculture, they can continue to grow the agriculture crop. So this type of land technology is required where the farmers are growing the brackish water land, or they are converting the agriculture land for the brackish water aquaculture, so that the adjoining farmers should not be suffered of the seepage of water. And CSR has been work on that, and the reclamation of the abundant aquaculture of some of the techniques or package of practice has been developed for that. If abundant aquaculture pond is there, how to bring that abundant land to agriculture practices. Again, the leveling is required, and sometimes drainage is required for leaching of the soils. You need to apply zinc sulfate, and selection of salt tolerant variety. Sometimes salt tolerant variety is required, and specific nutrient management practices. So that in that process of treating the abundant land, we can get the rice yield from 3.8 to 5.6. So this is another management practices of the aquaculture, abundant aquaculture ponds. So subsurface drainage, already Dr. Yadav has been already told you, is very effective in for coastal area for leaching of the salts or high water table conditions. I see this is the water table before drainage, but after putting subsurface, water table has been gone down, and this is the one of the example impact of the in the Guntur district. See here that this much salt has been removed from 7.5 after 6 years. So this slowly this salt has been reduced due to introduction of the subsurface drainage system. So before SST and after SST, remarkable change in the agriculture productivity. Already in details, Dr. Yadav has told you. So another is floating agriculture. I have told many technologies for the to overcome or to manage the coastal salinity in that area. You know, the coastal areas, many areas, they are not being used for the agriculture crop production, because sometimes most of the year, around 6 to 7 months, or 8 to more than 8, then more than that also is being waterlogging during the almost throughout the country. So it's not possible to grow the crop. In that case, we can go for the floating agriculture or the aquaponic. It's a very sustainable technology, and it supports the lives and livelihood of the people. And most of the cases, the traditional knowledge has been being used in that floating agriculture. And sometimes in aquaponic systems where crops are grown in just above the water, and the fish is grown under cage below the water surface. So it's a in the unutilized area where waterlogging is there, no crops can be grown. This type of technology is very popular in the Bangladesh, but in Indian condition it's not much popular, but there is very lot of scope for this practicing the floating or aqua agriculture or aquaponic system in that area. Now I'll be talking about almost come to the end of my presentations. Coastal land zoning is very important requirement for the sustainable management of the coastal lands. For restricting the degradations and all this, means allocation of the land for the different activities, maybe agriculture, freshwater, brackish water, aquaculture, and other activities. And the areas we should allocate the land which is suitable for particular activities. Like for examples, based on the most suitable zone, immediate suitable zone or unsuitable zone, we should go for the different practices. For example, in the brackish, highly saline land, coastal, highly saline coastal area, we should go for the brackish water agriculture, not in the agriculture, land where salinity is very less. So we should allow the crop to grow in the low saline area, and high saline area we should go the brackish water. See, this type of coastal zoning is very required for the management or sustainable management of the coastal saline soils, and also the sustainable management of the agriculture. So, and time sharing also very important. Whether rice streams allocate means a rotation, what should be we should go for the alternate freshwater or brackish water agriculture. This type of time sharing is required in the coastal zoning. Last, I'll be talking about the integrated coastal zone management. This is also another approach to address the current and long-term coastal management issues, including habitat loss, degradation of the soil water quality, soil quality, and hydrological soils. It's a holistic management process. We can where the landscape component, anthropology component, and resource and services are being integrated in the integrated coastal zone management practices, and it's very effective for dealing with the conflict. Sometimes very conflict is arising for different users, those who are using in that area. One of the example of the conflict is the brackish water aquaculture. With the farmers are brackish water always conflicts with the farmers, those who are growing the agriculture crops, and brackish water farmers and the agriculture always come. This type of conflict can be resolved through the integrated coastal management approach, and it aims at coordinated development and resource management of the coastal area. Thank you very much.
Hello, thank you, sir. Thank you, Varman, sir. Thank you very much, sir. Thank you. Very nice presentation, Rakshap. Very nice presentation. You have debate to mention, sir. Very elaborate, sir. Very elaborate. You have mentioned that what are the about 14% of the Indian lives in the coastal areas, sir, and 80.6% of total saline area that's covered by this coastal salinity. And geoclimatic distribution of coastal salinity, salt affected soils on the basis of rainfall is very essential, sir. And acid sulfate soil that is covered particularly found in the 2,000 to 3,000 millimeter rainfall area. And how very well defined that saline soil as well as the acid sulfate soils, and degraded coastal lands by the anthropogenic activities that has been done by the activities. How coastal degradation is done by the cyclone sea level rise after in the present condition as compared to the previous one. Pyrite is the main input that has create the acid sulfate soil, sir, and which create the toxicity of aluminium as well as the iron. Right from coastal region, zero tillage is very much visible for the coastal region, sir. And brackish water agriculture is also most popular. Thank you very much, sir. You have a very important and very informative speech, sir. Thank you very much, sir. Now we call Dr. Khaled Honkar, sir. MJ Khaled Honkar. He is the project coordinator of the AgriCell and Central Soil Salinity Research Institute, Karnal. I would like to share his brief biodata. Dr. M.J. Khaled Honkar is a project coordinator of EICRP on management of saltified soil and use of saline water in agriculture at ICR CSSRI Karnal. He joined the ICR in January 1992. He worked at ICR CSSRI Karnal, Directorate of Water Management, Bhubaneswar, and National Institute of Abiotic Stress Management in Baramati, Pune. He was earlier associated with AICRP on groundwater utilization at IIWM, Bhubaneswar. His area of research are reclamation and management of waterlogged saline soil, monitoring and evaluation of large-scale subsurface drainage system in Haryana, Maharashtra, and Karnataka. Testing of drainage filter for SSD system, regional scale salinity modeling, conjunctive use planning of saline sodic groundwater in good quality water, biodrainage and IFC model. He has created groundwater recharge structure and groundwater recharge planning for Karnataka as well as the Tamil Nadu area. He has published 10 international and 30 national papers. He has written many bulletins and book chapters. There are 2 national awards in his name. First is for his work on auto irrigation system from NRDC, New Delhi, and second one is for groundwater recharge work from MOWR, New Delhi. He is a reviewer of many journals and is associated editor for ISAE in New Delhi. He also contributed for national guideline of subsurface drainage system. He has worked for national international funded project. He has a vast experience of research, coordination as well as the administration. So I would like to invite Dr. Khaled Honkar. Please give your speech, sir, on the topic of this regional scale distributed model for salinity management. Please, sir, most welcome, sir.
Entire screen. From PowerPoint. With 2 monitors, share computer, and since you don't share screen, share entire screen application. क्यों नहीं आ रहा है? नहीं यार ये कैसे नहीं आ रहा है? इंदिरा जी भी नहीं होंगे ना? Chrome tab में जाओ. application window, entire screen, your entire screen, entire screen, entire screen. यादव सबको बुला लो, यादव सबको फोन करोगे, हे यादव सब आ गए। हेलो यादव साहब, या स्क्रीन शेयर करने का बता दो ना। हाँ हाँ हाँ, नहीं 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 नहीं, शेयर स्क्रीन फिर आ गया इसके अंदर। हाँ, क्या कर दिया? हाँ नहीं नहीं, मेरे पास आ जाओ ना फिर। हाँ, एप्लीकेशन विंडो। हाँ 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 हाँ, अरे आ रहे हैं। एप्लीकेशन विंडो, एंटर स्क्रीन, एंटर स्क्रीन में ये आना चाहिए ना। सब शेयरिंग ये कैसे आता है? ये खोल के रखिए ना। या तो सब शेयर करके दे दो, ये क्यों नहीं हो रहा है? देखो हमने तो खोल के रखा है। ये शेयर करो। हाँ, ये शेयर ठीक कर दिया। इसके बाद योर एंटायर स्क्रीन, एप्लीकेशन विंडोज, इसमें जो भी है आपका वो देखो कहाँ है। खोल रखा है आपने? खोल के रखा है। शेयर करो यहाँ। ठीक है, नहीं आ रहा है, ये खुल ही नहीं है। ये देखिए, एक बार फिर उसको बंद करो, एक बार फिर दोबारा करो, इसे बंद करें। ये है हमारा, यहाँ से कैसे हो सकता है? ये देखो, ये आ गया, ये आ गया, इसे से इसी से हो रहा था। ये तो वैसे तो कैसे किया जाए इसको? ये स्टॉप शेयरिंग ये हो जाता है यहाँ से। ये स्क्रीन शेयर, यहाँ आप कैसे गए थे? मैं किसी से गया था शेयर, यहाँ शेयर करके दी। करो, इसी से आ गया था। यहाँ से करके देखो, एक बार क्लिक करो। यहाँ क्लिक कर दिया, शेयर करो, शेयर कर दो। क्या हुआ? वो नहीं कर रहा है इसमें, स्टॉप शेयरिंग पूछ रहा है। तो आ रहा है क्या उधर? इनको दिख रहा है क्या? नहीं दिखेगा। हाँ, आपको भी दिखना चाहिए ना इधर। हाँ, आपके उसमें यही आना चाहिए। कैसे किया यार? सारे लोग बैठे।
सर प्रेजेंटेशन ओपन करिए।
नहीं, वो हेलो, शेयर हो नहीं पा रहा है
सर।
हाँ, शेयर हो नहीं पा रहा है, कोशिश कर रहे हैं हम। मतलब उसको कहाँ है वो हमारी? ये है ना? हाँ हाँ, हेलो हेलो, शेयर की पूरी कोशिश। शेयर हो नहीं पा रहा है, वो देख रहा हूँ मैं। यादव साहब भी बैठे हैं मेरे पास। हाँ बैठे हैं, या फिर किसी कमरे में चला हाँ ये हाँ ओपन कर लिया है। ओके, एक्चुअली हमारे यहाँ इंटरनेट गया था, इसलिए प्रॉब्लम।
हाँ हो गया ना सर। फुल स्क्रीन वाली बटन वो कप पे क्लिक कर दीजिए। कप होता है ना यहाँ राइट बॉटम कॉर्नर पे।
नहीं है ये, यहाँ राइट बटन, ये राइट बटन। हेलो, हाँ आ गया क्या? ये इंटरनेट गया था इसीलिए प्रॉब्लम हो गया।
आ गया सर, आ गया सर। ओके सर, गो अहेड सर, गो अहेड, गो अहेड। आ गया सर, ठीक ठीक।
करें। हाँ, आप सभी को नमस्कार। मैं थोड़ा सा हटके बोल रहा हूँ, और डॉक्टर यादव covered the overview of the soil salinity and the sodicity management in the India. Dr. Burman covered the coastal salinity. My topic is about regional scale salinity modeling. Modeling is a tool to understand the different issues. You can create so many scenarios and understand the which things you cannot understand easily in physical sense. So here we have tried to do the regional scale modeling. Modeling has been used to understand the regional salinity scenario in case of conjunct use of saline and canal water in Kheri command of the Bhakra system. And then we try to give the conjunct use plan, which would be sustainable in the long term. And there is a criteria for doing that. That is the availability of irrigation water that should be ensured in the conjunct use, as well as we know we must know the salinity levels in the root zone. Those should not exceed the threshold salinity levels of the crop, and accordingly we should. That is the concept. Introduction is the conjunct use of surface and groundwater is necessary to avoid the uncertainty in irrigation water supply, and use of poor quality groundwater is common in semi-arid and arid regions, and around 30 to 84% of total groundwater use in different states is of saline or alkali water. So the use of poor quality water in the agriculture is huge. And then definitely there is effect on the crop productivity. And if you take the case of the Haryana, alkali water is 21%, saline water 36%, Yamuna and Gangga basins. The parts particularly, these two basins are present in Haryana, and these basins are having no natural outlet. Means because of that, there is a build-up in the salinity in groundwater. Western Jamuna Canal and Bhakra systems are there. They also bring the salts to this basin. Haryana is a depression, and there is no natural outlet. So, and this canal waters bring salts also. So there is build-up in the build-up of salt in the groundwater. And conjunct use is one of the options to control waterlogging and soil salinity if it is at a mild stage. So conjunct use of a canal saline and alkali water with the groundwater is a practice in Haryana, Bhakra system and Western Jamuna Canal system. Improper conjunct use leads to rise or decline of the water table, then the waterlogging and soil salinization, irrigation induces salinization and alkalization, groundwater quality deterioration. If you don't do the conjunct use properly, these are the situations, and therefore we see the decline of water table in parts of Haryana and Punjab, as well as rise of water table in the southwest Punjab as well as southwest Haryana. And these mainly because these things are happening, mainly we are not properly managing the conjunct use at a regional scale. Conjunct use has two parts. One is at regional scale and other is at farm level, means at local level. So both things are to be managed properly. Now, I will be talking the modeling study, and my study area is the Kheri command of the Bhakra system. It is in this southwest of Punjab, and the Kheri command uses saline groundwater. it is increasing, use is increasing, and enhance the soil salinization and lower water table. Crop yields are low compared to fresh water. Develop integrated consumption policy at a command level to tackle these problems. Objective of the studies to study the salinity scenario in the command under present consumptive processes. Then we can assess the points where we can improve, assess the sustainability of the present policy, and develop guidelines for the improved consumptive use policy. Now, Bhakra system, where we are, and within the Bhakra system, we are working in the Kheri command. It is a part of Gaggar Basin. It is located in Fatehbad district. It is around 23,000 hectare area of the command, 80% cultural cropping intensity, and the length of the command is 50 kilometers, and it has so many miners, and 88 outlets. So you can understand the physically how irrigation system is there. Then the topography is flat, the climate semi-arid, soils are light textures, and groundwater more than 9 meters from the ground surface, saline water, basically no RAC. And it covers, it comes under the Hisar 2 irrigation circle of Bhakra system. Varavadi system is followed, and cotton bajra, it is a cotton wheat rotation. So basically cotton in the Kharif and the wheat in the Rabi seasons, and other crops are bajra and sorghums, and Rabi crops are barley and oilseeds, mustard like this. Data acquisition. For this study, modeling study, we took the data from these different sources. Saline water experiment, we got the data from Ramesh, then the soil properties, groundwater quality, HMITC, groundwater quality in Haryana, Manchanda, weather data, then the canal system operation. Then we also need to verify our results with the regional scale, field level, and those data were collected from the Shakti Vedal, that was the EMI project, and also we use the salinity intellection developed by the Usterban. The metrology, there are 3 parts in the metrology in this study. The regional water balance to assess the irrigation availability. When you go for any consumptive use, you must know what is available with you, and for that purpose you need to do the regional water balance. Then the regional distributed salinity modeling to assess the salinity scenario. Whether the present consumptive use is good or not, that is to be assessed on the 2 points. That is, you are able to do the sufficient irrigation water availability within the spatially and temporally, as well as the salinity scenario within the command. And then after understanding the salinity scenario availability, then you can propose the consumptive use planning considering the both as a criteria, irrigation water availability and root zone salinity. In case of regional water balance, water balance means water balance should be ensured that there should not be long-term decline or long-term rise of the water table, and then therefore the change in the groundwater storage should be more or less stable. Means it can be achieved provided the groundwater recharge and groundwater withdrawal is equal. Means change in the storage should be 0, and it means recharge and pumping should be almost equal in long term. So the groundwater availability is assured. Then regional scale distributed modeling. The distributed modeling is something different. You need to, if you need to consider a plane, and we are doing with 1.1 dimensional modeling, 1.1 dimensional modeling, and if it is to be done for a large scale, then you have to have several points, modeling points in the plane, it means in your region. And if you do that, if you simulate at different places, at so many places, then you can assess the regional scale. Of a 1-point model, if you want to take for the regional scale modeling, it has to be validated first at a point, at a particular point,
calibrated and validated. Then it should be applied to the different points. Then you will simulate the scenario, and that scenario is to be again validated. A regional validation means at a starting point, point validation is required. Then you apply it to regional scale, then regional validation, and then interpretation of the simulated results, and then the analysis. And in this study also, UNSAT chem model was used. It was validated at a point first, then it was applied to regional scale. Again, it was validated at a regional scale, and regional validation was done. And then once we got satisfied about the regional validation, we did the interpretation of the simulated results, and very good results we could get from the modeling. UNSAT chem model, it is a water and solid transport, and this is the movement of water to the unsaturated zone. That the change in the water content we can understand with the change in the water content with the spatial scale is in root zone, and H is the you can measure directly water content in the water pressure head, and volumetric change in the change in the is equal to change in the head, and hydraulic conductivity you need, and other things. S is the same term, is a research equation that is used in modeling study. Now, water and salt move together. So you need, then if the water movement is there, then salt movement is also considered. And what solid can be in this solution phase, adsorb phase, or it can be in precipitated phase. All three phases are considered, or it may come from this precipitated phase to solution phase, or adsorb phase to solution phase. All changes in the three phases are considered in an UNSAT chem model, but two phases, when you consider the movement of salts in saline condition, the adsorb phase and the precipitated phase we ignore. So it is one first term, that is change in the water content and change in the solution concentration. That solution phase is only active, and CK, that is the K can vary. It can be calcium, it can be magnesium, it can be sodium, and any other things. All those anion, cations, and anions in solution phase are considered. But when we apply this equation for the alkali condition, then you need to consider adsorb and the precipitated phase also, because calcite can come again to solution, and calcium may go out of the system. So all three complete equation is needed when you consider the alkali situation. But only one component, that is the solution phase, is considered when we deal with the saline situation. Now, we took the data from the MANESH. We considered two conjunctive modes, phenol and saline alkali, and then blending also. We calibrated a model with the saline and alternate mode, and validated with blending model. Saline water was of 12 EC SAR 10 EC, and canal water was 0.6 AC, time-dependent boundary conditions, solid transport at top, and free drainage at bottom, because water table was more than 9 meters. So free drainage at a boundary bottom stage we consider. We calibrated model, which was wheat crop. We consider all those things, the irrigation, the fall, and the soil properties, then the Gaffin coefficient, and the residual moisture content, then saturated moisture content, then all these things we consider, and we did the modeling. Then also quality parameters of saline mix and rainfall water, and these results could get. We could match the observed, our simulated curve with the observed curve, and the model was first calibrated, then it was validated, and then we got confidence that yes, our model is working at a particular location. We can take it to the regional scales. Means we can simulate the salinity scenario within the command by simulation of the model at a different locations. It can be any, it can be n, it can be 10, n can be 20. But if n is higher, means the model locations are higher in the command, then you can reach to more accuracy.
Information available, which aspect of the proposed project will generate new information.
Then the modeling with distributed data. I said that we selected around 6-7 points. Then we consider the soil, irrigation water, quality, and all those things at those locations. And locations, Siran, Karhan, Khabra, Khurd, Dabra, Kalan, and Nayar. So, and within the we ensure that we address the soil texture of different, according to the homogeneous location groups were made for the soil textures, and accordingly we select the locations and we address different soil texture situations in the command as well as the soil quality, then the groundwater quality and all those things. Of course, it was important with rotation, and you can see the command we have selected different groups, and we estimated the soil properties, soil physical properties, chemical properties, everything. Then we have groundwater fluctuation within the command. It was before the irrigation water table was very low. It increased with the irrigation, which means percolation losses. Irrigation was introduced because of the Bhakra system. It came up, but as irrigation intensity improved, it went down. So this was the situation of regional balance and the groundwater quality in different locations in the command. We took this, and we have textural situation, we have groundwater quality, we have crop rotation, everything we have, and then we went for the simulation by a single point model, a one-dimensional model at different locations. And then we need the irrigation intensity because we need to know the pumping from the groundwater that is to be estimated, what amount of water we get from the canal. Then we have to do long-term simulations. So we need to know the irrigation intensity during the 1985 and 1996, all those things, and accordingly we have to improve during the modeling. All these things were considered. Then you require to consider the transpiration requirement of the by the crop, and we accordingly we consider the rainfall. Then the ET, first we initiated the calculated the ET requirement by crop wet model. Then we saw the availability, what can be the what amount of water is met from the rainfall canal, and what will be the probable pumping from the groundwater that we estimated for the wheat crop. Then we did crop irrigation planning for cotton crop. What is the intensity, the amount required, the rainfall canal, and total pumping from the aquifer. So these are the ways. Then we did the long-term simulation, then suitable boundary conditions at top and bottom, and then we simulated the scenario about the salinity, root zone salinity within the command, and we could say with confidence that the simulated salinity and observed salinity were matching. We were appropriate in assumptions, and we could say that and we also predicted the yield of the after validation of the root zone salinity, we could predict the yield of the wheat in the different zones, and we could simulated yield and observed yield also match within the ranges. Then the conclusion of regional salinity modeling. Regional salinity modeling with the distributor can view the regional salinity scenario within command, and it may be effectively used to impact analysis of irrigation project in ANFAS. It has two advantages. It can be used as a what has happened because of the irrigation, and you also can use what can happen in case of the advance. Now it means our analysis start from this point, assessing the sustainability of wheat and cotton rotation command, considering the availability of irrigation water and salinity criteria, identify critical areas in the command and developing guidelines for sustainable conservation use. Now, annual recharge. When we consider initial assumption was that the groundwater change in the groundwater storage should be zero. So, with improving the irrigation intensity within the command, improving the groundwater use means increasing the groundwater use. We need to know whether our present consumptive use is sustainable or not. And so we try to understand what is annual recharge within the command. And these are the values with time. And then we try to see the groundwater pumping for the wheat, what much amount we are taking out for the, irrigating the wheat crop over the years. Also, we study the cotton in case of cotton crop. Then we try to know the what is the annual groundwater pumping within the command, and then we compare it with the groundwater recharge. And we found that the average groundwater recharge rate was 13.4 and average pumping rate was 13.04, means the system was stable at that point. Rise of water table was 0.34 and observed rise was, simulated rise was 34, observed rise was 0.54. So initially groundwater recharge was less, then the groundwater means overall system was stable. But if you first first 5 years pumping rate was 10.27 and second 5 years it was 15.82, means it is mainly because of increase in the irrigation intensity. Means at the present the system was stable, but if you go on increasing the area further, the system can be unstable. Now, groundwater fluctuations and the reasons have been shown, and now we want to, according to irrigation water availability, we have answered the question. The system is stable, but it can become unstable if we increase the cropping intensity, particularly of cotton crop, because there is a little scope of improving the irrigation intensity, cropping intensity of the crop. So that should be avoided. Now we want to see the salinity changes in the root zone at a different location we selected, and these are long-term simulation for the 10 years was done, and these are the salinity, root zone salinity values. We got from the simulation, range 0 to 30 centimeters. So you see it has reached to always below the coast at Khabra Khurd location. Then accordingly we did it for all the stations and try to see what is happening there. If the salinity is above 4, means it is crossing the threshold salinity of wheat crop, there will be yield reduction. And from this simulation, we can understand that the only 20% chance there will be no yield reduction within the 10 years or 11 years. So all the time, the wheat crop will be affected because of the salinity at 3 locations, that is Siran, Kiran and Khabra Khalan. But at Dhabi and Khabra Khurd location, the chances of failure of the wheat crop due to salinity are relatively less. At Khabra Khurd, no wheat crop will be affected because of the salinity, because groundwater quality is a little bit good and the soil texture is coarse. So at Khabra Khurd, we are not worried about the effect of the salinity on wheat crop, but at 3 locations, almost 80% chances are there that our wheat crop will be affected because of the salinity. So what is happening with the wheat crop? We did the similar type of the analysis and we found that there is no chance that our cotton crop will be affected. Only wheat crop at 3 locations is affected because of the salinity, and cotton crop, you can say, it is always, soil salinity is below the threshold limit of the 7.7, and all these results are based on the simulation. Salinity is below below 7.7, so there won't be any yield reduction in case of cotton. In wheat crop, at 3 locations, in 3 pockets, there will be yield reduction. At 2 locations, remaining 3 locations, there won't be yield reductions. So this is the important input we got through this simulation. And now we can plan the conjunctive use. In conjunctive use planning, there are 2 aspects: a regional scale conjunctive planning and the field scale conjunctive planning. Here we can do the manipulation at a regional scale conjunctive planning, means we can use the fresh water, fresh canal water to 3 pockets, that is Sirhan, Kiran, during the initial stage of the crop, of wheat crop. So there won't be, because the crop is very sensitive to the salinity during the initial stages. So if we use the canal water to Sirhan, Kiran and Khabra Kalan during the initial stages, and then the Dhabi, Khabra Khurd and Dayar pockets should be asked to use the groundwater during the initial stages. So actually, by this manipulation, we will be able to increase the wheat yield of irrigation command by 10 to 20%. And cotton crop, there is no yield reduction because of the salinity, but there is one alarm, that is the cotton requirement, irrigation water requirement is high and our availability is limited, so you cannot increase the cotton cotton crop area in the command. Otherwise, the water balance will get disturbed. So conclusion is that average pumping is equal to an annual pumping at this stage, and it is stable in a long term, because we should not increase the cotton intensity in the command. Pre-sowing irrigation by canal water, particularly for those pockets where the wheat crop is affected because of the salinity, those pockets should get the canal water for pre-sowing irrigation and the early stage irrigation. In critical areas, grow wheat by canal water, that I told you. Multi-cropping to avoid the pumping during the Rabi season. We are at a built natural balance, at a delicate balance. If we improve the intensity of any crop, where that balance will be disturbed. So instead of going from one crop, we should go for the crop diversification, and for the in place of cotton, at some places we should go for the bajra, sorghum, or at some places we may go for the agroforestry models. In the wheat Rabi season, pumping of the for wheat crop, pumping from the groundwater can be reduced by if you go for little bit for the mustard. So cropping intensity, we have worked for the different crops, and cropping intensity of cotton should not exceed the 50%. That is the maximum limit where the cotton can be grown in these commands. And some area can be shifted toward the agroforestry to reduce the demand of the water in long term. So regional scale modeling with the distributed data is able to give the salinity scenario within the command. And sustainable consumption use, you need to consider the irrigation water availability and rural salinity as important criteria. So thank you very much for patiently listening.
Thank you, Doctor. Thank you, Khaled Ronkar Saab. You have really very well dealt this regional scale distributed model, sir. How this improper conjunctive use leads decline of the water table, water logging, as well as the salinization and groundwater quality deterioration. Very well documented, sir. How command of Kheri distributed water system and create the regional distributed salinity model after acquiring data from different sources of workers, research workers, and develop the onset model. Very well, sir. Problem equation models are very much effective for sustainable groundwater and cotton intensity may not be exceed, that will be about the 50%. Thank you very much, Dr. Saab. Thank you very much, sir. May I invite Dr. S.K. Verma, who is the former Dean of College of Agriculture, Gwalior. Before inviting, I give you some brief introduction of Dr. S.K. Verma. Dr. S.K. Verma was born 1954 in Tanda village of Ambedkar Nagar, Uttar Pradesh. Dr. Verma did his post-graduation and doctorate from JNKV Jabalpur and started his services from JNKV Jabalpur as research assistant in salt-affected soils project, College of Agriculture, Indore. Later on, his post was upgraded to junior scientist in the same project. He had served his services for 30 years in SAF, salt-affected soils project during 1978 to 2008 and involved various technologies for reclamation of body soil, including raise and sunken bed method and strip application of gypsum. He had become senior scientist in charge of SL project Indore since 2003 to 2008. He became in 2004 emeritus professor and head of the Department of Soil Science and Agriculture Chemistry, RVSK Gwalior. Then he worked as dean in the same college from 2018 till his retirement 2019. During his long tenure, he had handled so many projects in JNKV as well as the RVSKV Gwalior, including NWDB, NATP, ISRO, Mandi Board, and MP CPCB, RKVI, NICRA, etc. Out of many projects, he handled 4 big projects amounting crores, 3 crores Government of India, 4.08 RKVI, 4.6 ICR, and 2.0 NICRA project. He established stationary as well as the mobile soil testing laboratory in Government of India project. Later on, he worked as principal investigator in RKVI project for the development of farmers' soil health card. Under NICRA project, he did his work on identification of efficient integrated module for the sustainable management, ravines, chambal, and carbon sequestration for climate resilience in Madhya Pradesh. He has also done a good work on management of soil health and productivity in ravines, land under which area of excellency RVSKV Gwalior. So I invite Dr. S.K. Verma, please give your talk on the management of chambal ravines. Please, sir.
Hello, good afternoon to everybody. Myself S.K. Verma. I have worked as a scientist for about 30 years in soil salinity, and my interest was even more in soil salinity. But during last decade, when I got posted at RVSKV Gwalior, then I have got some funds. I have worked on this ravine reclamation, and really in a salinity project, we have contributed a lot from Indore Center, that is to for Berti salts and sodic Berti salts. We were first who introduced pyrite as an amendment. Otherwise, before 1983, it was considered as substandard grade and never recommended for use in Indian condition. But we have given complete technology, how it should be applied, in what quantity, and how, and it proved as good as gypsum. Because we get one project from this PPCL, Pyrite Phosphate Limited India, during 1982. Then we have contributed dry farming technology for reclamation of sodic Berti salt. And then again we have raised and sunken bed system was given by this center only And so far, even natural technology, just like grass. Okay, sir. Come on. दिखे तो नहीं अपन. हेलो हेलो हेलो.
हाँ सर बोलिए. आ गई.
हाँ सर.
ठीक.
हाँ आ गई सर. बोलिए सर.
So when in 2012 I visited the Ravine, then the Vice Chancellor, respected Dr. V.S. Tomar, actually he thrown me in that Ravines for doing something, because since last 400 years people were working there. Even during the English time, some work has been reported there, and no success has been made there, and the ravines are still there. So it was thought that most of the area comes in this our jurisdiction, so we have to do something, and we got the success, no doubt. I started this work right from the work, the survey of problem, what is the intensity and how it is. Feedback by affected. Actually, I got a lot of feedback from the peoples who are cultivating in their area, how it is farmed and how they can stop it. And major of the issues I got from there only. I have visited many villages during extensively around 60 kilometer along with the Chambal command. Actually, Chambal command is Chambal river is altogether different than any other region. The ravines formed by Chambal is not considered as it is written in books, or you cannot classify them shallow, medium, or this deep ravines. Even how they are formed, it is altogether different. We cannot. So it was a big problem for me, at least, to start the issue. So I have visited one temple there inside the ravines, around 3 kilometers. We have traveled by almost by feet. By foot, and then we saw that the people said that there was a village here, and now it has got shifted about 8 kilometers on the Agra Bombay road, that is known as Kali Devi, and but temple was still there, and is still Deori in that place, and they give me lot of idea how they are protecting that temple. That area is still safe. Even it is surrounded by all the direction by ravines. So feedback had given me some. So then we started the thing. Visit of ravine along with river, as I said. Survey of vegetation available area. We surveyed extensively the vegetations available in that area, so that we can screen out the resistant crops and other things. Meeting with the affected villagers and application of watershed. We started our work on watershed basis, but treatment started from top table surrounded by table land, and application of watershed based and contour survey was made by us. We have selected 100 hectare of land allotted by the collector Morena, and application of different conservation structures. We have applied permanent, semi-permanent, and other structures. Test efficiency of different machine. Even we tested the machineries that can help us in controlling or labeling or anything. How they can be utilized. Section of crop and plants. computation of economics and other things we have started it too. So everyone knows that there are about ravine lands are about 2.06 million hectare is ravine land. Out of this 2 million hectare, about 90% is in either Uttar Pradesh or Madhya Pradesh. And in particularly in Chambal, there is a report that it is still increasing by a rate of 8,000 hectare per year. The report was published in 2004. So we looking to all these things, we started work there, and we have found that there are several rivers in this Chambal area, that is Bhind, Morena, Datia, Gwalior, and Shivpur districts it contains. So Chambal has a major area, no doubt, and the second is Sindh. So the Chambal has a typical things that have attracted us to work there, because you can see here Morena, Bhind, Gwalior, and the total area in this yeah. Problem of the region: ravines are gobbling up villages and communities in Bhind and Morena, destroying the houses and wasting away the soil. It is estimated the ravine have affected 948 villages in Bhind and Morena districts. Mirgpura village in Morena district is being globed up by the ravine so rapidly, the land around it has been turned into deep pits, and the village is now divided in 18 parts. That is, you can see the the village was original village was somewhere here, and then it got shifted to this place. Now this has been shifted to many small localities, about 18 parts. So likewise, the other villages are also originally it was here and then got shifted here. Then now it is at present it is here. So likewise, many villages they have got, and some work has been reported from this area in last decade. So we have collected the information. Soil conservation scheme were carried out in 1955 to 1973, and centrally sponsored scheme was there 71 to 77. Ravine erosion control scheme was operated there in 1977 to 87. Dacoit prone schemes were launched there 1988 to 1992, and Forest Department also done some work in this area. But the issue was still in same line, and nothing was visible there. And even before this English time and Scindia state time, some work has been reported. But the things are, when I visited the first time along with our respectable Vice Chancellor V.S. Tomar then, and a team of scientists from college and department, they all commented, there was a comment, general comment, nobody could do here so far, so we have to see what you can do here. So I started with this remark that let me try here. So then many efforts has been made and no solution was found. Why these ravines are deep from it? This is a typical nature of these ravines. If you visit, I visited first time in this 2008 or 9. Then I saw the problem. Right from start, it is sometimes 10 or 15 meter deep, and above that there is a level line just above that. And why these ravines are deep from start? So we have to search out the problem, how it is going, why still advancing in new field. Even I have visited one farmer field. He told me that I had 1 hectare land here. Now I have only half hectare, because half hectare has been washed away simply in one day. and he showed me the stubbles of this mustard and others lying about 10 meter below there. And he said that then I asked him, how it happens. So then he said that the rain was continued for 3-4 days, and after that all the land has slipped and went to the how it can be checked. So our serious thing was that it must be checked so that it might not increase further. Losses, we have computed the losses from the ravine are glowing up village communities in Bend, Morena and Shopir. About 1,053, 44% of village in Bend, Morena and Shopir are affected by this. Miragpura village, as I told you, that it is divided into, in Porsa, Morena, there is another village that is losses due to ravines, about 0.73 million tons of organic carbon per plough layer. I computed from plough layer base. And 10.95 million tons per year of silt load we are losing there. And 821.65 meter cube rainwater every year it is going off as runoff, losing many thousands million tons of soil every year. And we have estimated the NPK and other losses to run off the soil. So there is heavy loss from the soil, and but this soil have even better potentials also, that if it can be utilized by the techniques and other things. So the potential is that fruit, vegetables, and fodder for the whole of the central India can supplied by this region only. Potential to produce 3 million tons of food grains annually. How our potential and medicinal production can be converted. Conservation of rainwater, and that's why losing of the silt and other things, we can conserve lot of resources. Great potential for carbon sequestration, as it is a vast, actually vast land and mainly sand. So there is a potential for carbon sequestration. We can use it. Great potential for tourism even. Sorry. Yeah. How it is developed? Actually, we try to understand the problem. How it is. Contributing catalyst of the region are elevation difference. First is elevation difference. There are about 20 to 40 meter elevation difference between land and river bed. Soil texture is another reason. Alluvial in nature, and sand fraction increases with depth. Hydraulic properties, high infiltration rate facilitate downward water movement. We have measured about, you cannot imagine that there are 9 to 10 centimeter water passage in an hour. High hydrodynamic pressure. The moving water, downward moving water, along with this silt loss, provides a hydrodynamic pressure to pass towards the low potential grade. So subsurface flow starts towards river at the depth of around 35 meters. The dispersed condition of soil is another reason, that there is no organic matter in soil, and there is a minimum clay percentage. So this is the problem that you can see here, that it starts right from below the profile. The caving start, first caving start from here. Then this whole profile gets saved into the water and flown away to the river. So this is the process that we could understood from the people, and we have seen. And so major manageable issue for this area is kinetic energy is main reason for water movement. Infiltrating water plays a role in the development of this ravine. Soil binding energy is poor. it is needed to be increased through various options. Hydraulic gradient is to be minimized by increasing water travel length. It is one of the reasons that we have used in this. Hydraulic gradient is driving force or subsurface water flow towards river at a depth of 25 or 30 meters. The gradient difference indicate that potential for subsurface water flow direction. However, the actual flow direction is also governed by the permeability of the porous medium and by the geology. This is the reason how it is groundwater flow occurs and it when it get some vacant space, then it become free to move and it carries silt and sand with it and makes cavity below the soil and then when continuous rain is there. Otherwise, it is not get converted into ravines. If it is a continuous rain for 3-4 days, then the whole profile gets wet, and then after caving from lower layer, then it gets slipped out complete into the river and flown into the river. Here we can see. We have prepared one animated film, so you can see and understand this. Yes, sir. You have. I have tried to explain how it is formed and how it can be checked. So we have prepared a new map from the remote sensing data in 2013. That how much area is there still, and there is although reduction in the area because the silo. The problem here lies is the biggest problem is that the Chambal Ravan is under government control and it is government land. Otherwise, the other rivers like Kwari and Siwan and other, they have a medium or shallow ravines, and they are in control. They are with the farmers, and they have reclaimed those soils. But here in Chambal, the problem is altogether different. And being a government land, it is nobody is taking care so far, and that is the main reason that otherwise it can be converted into. So we have started some work there, and we started that. The other technology also that is written in book or published, that is for shallow ravines, although it is not there. For checking our advancement, we have changed the slope and edge. We have started work on this, and it is a powerful tool to check if you change the slope of the edge to in slanting position, then and plant there some grasses or shrubs, then it is good planting of pastoral system on slopes. The third, we have got two types of permanent solution for this, that is multi-step leveling and the complete reclamation. And we have estimated the cost under these two, and that is we started the reclamation cost also. If it is shallow, then it is only we need JCB machine, tractor, manpower, and the cost at that time came about 53,000 per hectare. If it is medium in nature, the Hitachi machine and the tractor, structures and manpowers worked for it was cost came to 1,75,000 per hectare. In case of deep, that is with the Chambal mainly, Hitachi machine, JCB, tractor, and structure, some manpowers we have utilized, and the cost came 3,70,000 per hectare. In case of deep, we have there was discussion with our Honorable Vice Chancellor and others. So, some people were against that. That it should be not completely leveled, but it must be utilized as it is, and keeping the its ravine nature live. Or so that we have started one multi-step leveling. Only we have labeled some land which is which can be converted into leveled position, and others were some were the mount were cut down and put some. And here we got that we have received that about 40% of land was leveled, and about 40% still remains in the sloping condition, and about 20% area came into this channels, and so the channels can be utilized as for conserving water. And this model was carried out there in 5-hectare land, and if you can visualize, this is not 5-hectare land. It becomes around 7 or 8 hectare, because slopy land, open surface is more than that aerial surface. So it becomes around 8 or 7.5 hectare from 5 hectare. So we started this and we utilized, and the main reason that here cost is very less, only 40,000 per hectare, and here you can get you can achieve the permanent solution, because after adopting this model, there is nothing loss like runoff water or a nutrient loss or silt loss. Everything was got conserved by constructing only this earthen dam after some interval, so that the kinetic energy of running water may not exceed that level, so that can be stopped before that getting momentum of the runoff. So this model actually is very successful, and we have control, and now anyone can see there. We have tried to structures and different temporary or permanent structure, but we have a Bori Bandhan, earthen burnt, masonry structure, avian, improved avian. That was our improvisation in Gavian, because I have taken help from the our senior scientists like Dr. G.P. Verma, who has a lot of experience for soil water conservation, and this Gavian structure was innovated by him only, and improved Gavian. The Gavian, original Gavian could not work out here because these sandy soil are highly permeable, and so water enters from any area and forms cavity, and then everything is goes out with the runoff water. Silviposter module, we have tried 4-5 module there, so we have found the silviposter module recorded minimum silt loss in these models, but from our different option of planting also were carried out. We have found that medicinal crops, Satawar, Urusa, Sugandha, Tulsi, Isabgol, Karil, Castor are well suited for the area. Medicinal trees like Neem, Karan, Jamun, Arjun, Bale, Mahua, Google are there, and timbers like Sisam, Sagon, Siras, Khamer, Babul. If you have time to visit, you can see there they are standing. And fruit trees like drumstick, aonla, and bear got successful. Grasses like lemon, munja, paira, pamarosa, marble, and napier are growing there well. Other also we have tried like bamboo, karoda, and lasoda. These are very good. So we have tried different modules also, how it can be utilized in natural condition. So we have soil water conservation. We found that silvipastoral system was good and followed by silvi-agroforestry. Economic purpose point of view, cropping system, because cropping system start returning money from first season only. So during start it was found very good, and agro-horti, then agroforestry. Most feasible system, you can say, that is agro-horticulture and agroforestry and eco-friendly system, silvipastoral, silvi-medicinal, and agro-horticulture system and work. Some work was done on the carbon sequestration and other things. So this has been reported from there. I consider this is the ravines of these areas. People can tell that this is not good for the area, but I think it is blessing for the area, and if it can be utilized properly. Land is 3-dimensional. Here you can get 3-dimensional land and make surface area more than 2-fold. If it is a 2-hectare land, you can get utilize 3 or 4 hectare land. Magnificent input use efficiency. Being sandy in nature, whatever input you are putting with proper technology gives 100% return. Rich in groundwater, the areas have very good groundwater and good quality water at a depth of around 40 or 50 meter. High density production due to increased area. As in area we get increased area, so density can be increased, high carbon sequestration potential. It has high carbon sequestration opportunity for many small scale industry, income generation to many-fold than normal lands. We can do here. We have done many, and opportunity for small scale industries is there. Honey production goes on in those area. Bamboo based industries can be set up there. Post harvest and value addition scope is there. Raw material processing for Ayurvedic medicine. There are many medicinal plants are naturally growing there, and only need to take care of them. Dairy and goatry is option for that. Fisheries can be done if we can put only earthen dams are successful there, and it has a minimum cost. It can be developed as ecotourism. There is opportunity. So now I am thankful to Google that we can get from the record that how we proceed, and it was before the start of the experiment. This was condition. This is a road, and it is here a temple, and this area was allotted to us by the local administration. Out of 100 hectare, I have chosen only 20 hectare for treatment. So here we have started after building a small sitting room and a small store, and we started the work and keeping the topography same as it was. And now you can see that there is a lot of vegetation in this area, and around 4,000 plants are there, and you can see there 30 to 40 feet plants with good establishment. Only thing that we have done that we have this area we have surveyed, and we installed the drip system and fertigation system, so that every plant at any elevation can get equal quantity of water and fertilizer with the time. And there was only termite problem here, so we have used termite termite for killing them at least twice in a year with that irrigation water, and we got success, and we still it is there, and it is around 20 hectare land is lush green, and the things are still growing. So there is no we don't have to give a big input or cost wise. We can improve them, and we have improved, and now it has almost 8 years has been passed, and now still it is in good condition, and now anyone can. In my opinion, Chambal ravines are developed as a result of typical location specific mechanical forces, and can be solved easily and permanently by breaking or manipulating these forces. Only we have to break the this hydrodynamic pressure, so that it can not further increase the area and cannot carry out the silt and other runoff water. So the only thing is, and that can be done only by this simple manipulation, and without any much investment, and we have got success, and no doubt, and the need is that honest approach by any agency is required. You have to be honest for input and other thing to take care like one baby. Just because during first 2 years, you have to irrigate almost twice a week, and being sandy in nature, the temperature goes as high as 48 and 50 degree in summer, and only one day is sufficient to kill all the plants and other things. So you have to take care every evening and every daytime, so that you can keep them alive at least for 2 years. Then they get established. Multi-step leveling is low cost on permanent solution. You can get table lands at some different depth and different elevations, and that can be used for cropping system, and the slopes can be utilized for grasses and these trees, all kind of trees, medicinal crops and other things. And the lowest region, that is ravine, that gully, it can be stopped at almost at 50 or 60 or 100 meter interval with earthen dam. A strong earthen dam is needed with the slope having 1:1 ratio, and with a wide base, so that works very well, and we do not need any permanent structure in this area. Land leveling with proper technology is costly permanent solution. Some people says that this can be leveled. No doubt, it can be leveled after expending about 4 lakh per hectare. But you will lose this topography and everything, and you have again take care that there must not be big plots or big open surface area. You have to divide almost not above 200 meter, 2000 square meter area. A land must be, and it should be protected by a wide this bunds and all these things is required there. Development, sorry, developed and transfer approach can be utilized here. Some agency or government can transfer this land to after development, transfer or lease. Even you can sell, or it can be given a lease to local people, so that they can do some cropping and other things. Involvement of national development agencies are required. The reclamation can be carried out in different phases, if not at once, because one project, when this BJP government came in second time, our Honorable Chief Minister Shivraj Singh had given 19 priority program formula to that. On that the government will work out, and we'll see. In that 19 point, this ravine reclamation was all, I think, 7th or 8th point to be considered by the government, and the Chambal commissioner was given the opportunity to submit a program. He formulated, constituted a committee. I was member of that committee, and but the thing was that he wants to reclaim all the soils in Morena, Bhind, and this Shivpur. So it was deep ravines was about 78,000 hectare, and work out that we have planned that it requires 11,000 crore rupees, and the same was submitted to the central government, and this some development agencies like this Asian Development Bank and others were approached, and they were ready to our central government to sponsor 9,000 crore. But the condition was that 2,000 crore must be expenditure made by this local government. Then we will release the amount. So still it is under consideration, but it is I think 4 or 5 years has been passed, and it is still technically approved, but could not be. So it is my suggestion that it can be carried out in different segments, and with the declaration can be different phases. The land can be transferred to group of farmers or society, because the approach is reclamation approach is needed to be in watershed basis. So complete area must be occupied by single farmer or say a single society or a unit of farmers, so that 5 kilometer wide along with this Chambal River. The land can be transferred to group. Okay, huge capital can be generated by sell out of the reclaimed land, because if you are putting 40,000 first year and then for 3, 4, 5 years, not more than 2 lakh you have to expend, and it can be sold. The land value there is around 15 lakh per hectare. So after investing 3, 4 lakh, we can earn by selling these land to 10 to 12 lakh rupees per hectare. So huge capital can be generated by government, but formulation is required, and it is work of executives to work out on these, so that it can be done. You can see that this is the view of that multi-step labeling, and we have got successful crops there, and everything is checked without any loss of soil, water or nutrient, and this is need of time, and this will certainly improve the environment also, and will give good contribution. Thank you to everybody. Thank you, sir.
Thank you, Dr. Saab. Thank you, Dr. Verma Saab. Thank you. You have given a very good lecture on the advice made by Dr. yourself, sir. You have also classified revise into different categories: low, medium, and very large, hard, and 25,000 hectare that has been reclaimed by different institutions since 1955 to till date, and loss of revise 0.73 million tons in respect of organic carbon, and 10.95 tons per year as well as in respect of silt. So carbon sequestration is the only way to improve this revise management. Similarly, in this 55 or 56% in the sand content, that is the main culprit for the formation of ravines. So spreading of only spending that 40,000 we can manage ravines. Sir, very good presentation, sir. Thank you very much, sir.
Thank you.
So may I request Dr. Ashok Krishna, Dean, College of Agriculture, for vote of thanks. I thank the Rajmata Vijayaraja Scindia Krishi Vishwavidyalaya for giving me this opportunity to express my gratitude towards all the communities who made this webinar a successful event. It's my great pleasure to extend my gratitude on behalf of the organizing committee to Professor S.K. Rao, the Honorable Vice Chancellor of the Rajmata Vijayaraja Scindia Krishi Vishwavidyalaya Gwalior, for extending the permission and providing valuable suggestions to conduct this webinar on problematic soil. Under his able guidance, the Vishwavidyalaya is working for the benefit of the farming community of the state and also for the nation with respect to the aspects of teaching, research and extension for the farmers. I am also thankful to Professor V.S. Tomar, former Vice Chancellor of Rajmata Vijayaraja Scindia Krishi Vishwavidyalaya and Jawaharlal Nehru Krishi Vishwavidyalaya, for delivering a very important lecture on keynote of problematic soils, especially the salt affected ones. I extend my thanks to most popular and respected Dr. S.K. Chaudhary, Deputy Director General, Natural Research Management, Advanced Agriculture Research in Delhi, for accepting our proposal of the webinar with a short invitation. I thank Dr. R.K. Yadav, Principal Scientist and Head Division of Soil Water Management, CSSR, to deliver a very good lecture on reclamation of hard-to-locate soils in a very systematic and effective manner. I extend my thanks to Dr. M.J. Khaled, Project Coordinator, All India Coordinator Project on Hard-to-Affected Soils and use of saline water in agriculture. Dr. Khaled Onkar's finished speech has given a good model of management of salinity in soils. I am also very thankful to Dr. Burman, Principal Scientist and in charge of Regional Research Station, Canning Town, West Bengal, who gave a very brief speech on how to control coastal salinity in our country. I extend my gratitude to Dr. S.K. Verma, former Dean, College of Agriculture, Galia, for giving a very good presentation of Chambal Ravine Management. I am very much thankful to the authorities of Rajmata Vijay Rajesh Scindia Kashmir Vidyalaya Galia, Dr. Mr. Mridula Billore, Dean Faculty of Agriculture, and Dr. M.P. Jain, Director Research Services, as co-patrons of this webinar, who have given valuable ideas and suggestions from time to time to make this webinar a success. At the last but not the least, I wish to thank all the staff members of the organizing committee, the supporting staff, professors, scientists, and associated students who have given full support and valuable time in making this webinar a success. Thank you all very much. Thank you very much, sir. Dr. Jain Saab. Hello, Dr. Jain Saab.
हाँ, thank you very much.
Sir, you are interested. Please tell us something.
All our participants and authorities, this seminar has successfully conducted by Dr. Bangar and the team of Indore College, and I appreciated that this webinar, which is the burning problem of this era, that how we can expand our cultivated land so that we can harvest the produce for our population. So this is one of the attempts we have made with the collaboration of Indian Society of Soil Science chapter at Indore, as well as Society of this at Karnal. We thank you all to participate. Thank you very much, sir.
Sir, thank you very much, sir. All of you, thank you very much. Thank you very much, sir. Thank you very much.
Thank you very much.
Thank you. Thank you, Kale. Thank you.
Namaskar, namaskar.
Now let us move towards the IDs.